In the stillness of a clear night, far from city lights, you gaze up at the sky. Countless stars shimmer against a velvet darkness, each one a sun like our own, perhaps with its own worlds circling around it. There is a gentle tug at your thoughts, an ancient feeling, as if the cosmos itself is calling out to you. For as long as humans have existed, we have felt this quiet beckoning. Under this same sky, our distant ancestors looked up in wonder, naming constellations and spinning stories about the lights above. They sensed, as we do now, that something profoundly inviting lies in the endless expanse beyond our world. From our earliest days, that sense of mystery has filled us with questions. What are those points of light scattered across the heavens? What lies beyond the horizon, beyond the moon, and wandering planets? We have always been explorers at heart, forever curious about the unknown. Thousands of years ago, we sailed across uncharted oceans to find new lands, guided by the stars above. In much the same way, the night sky has always dared us to venture further, to set sail into the cosmic ocean that surrounds our tiny planet. In our minds and dreams, we left the Earth long before we had the means to do so. Ancient myths, imagined heroes, carried into the sky by winged chariots or magical birds. In later centuries, writers spun fantasies of voyages to the moon and planets, stories of rockets and spacefarers when such things were still impossible. These tales reflected a deep longing within us. Long before the first rocket ever roared to life, humanity's imagination was already roaming the heavens. That dream began to take shape in reality in the mid-20th century. After ages of gazing upward, we finally built machines to pierce the sky. It started with a rumble and a flash, the first rockets breaching Earth's atmosphere, carrying the hopes of those who yearned to touch the stars. We learned to send satellites into orbit, and even living creatures skyward, tentative steps towards the universe. Then, in a moment that fulfilled the hopes of generations, a human being left Earth's cradle for the very first time. Imagine the scene. A bright April morning in 1961, a Vostok rocket standing tall on its pad. Inside a tiny spherical capsule sits Yuri Gagarin, a young pilot about to make history. The engines ignite, and the rocket rises on a pillar of flame. Within minutes, Gagarin is beyond the sky, weightless, watching the curvature of Earth out his window. For the first time ever, one of us is out there, in the silence where the stars don't twinkle. As he orbits Earth, a profound truth sinks in for all humanity. We can leave our home and venture into the cosmos. That first orbit was a triumph, not just of engineering, but of the human spirit. It was as if all those nights of stargazing had led to this, the barrier of space broken at last. Soon, more would follow. We sent women and men circling the Earth, and before long, we dared to go further. In 1969, human footsteps pressed into alien soil for the first time. The moon's powdery surface bore the imprint of boots from Earth. Think of what that meant. In the span of a single human lifetime, we went from riding horse-drawn carriages to walking on another world. The call of the cosmos had finally been answered in person. Standing on the moon, astronauts looked up and saw Earth as a delicate blue marble hanging in a black sky. For those watching back home, it was as if we too stood alongside them, feeling the wonder of that view. The Earth, all of humanity, all we've ever known, could be hidden behind an outstretched thumb. It made many realize how small and precious our world is in the vastness of space. This profound shift in perspective, seeing our planet from afar, has been called the overview effect. Borders vanish, petty differences shrink. One is filled with awe and a sense of unity. We had taken our first steps into the universe, and already it was changing how we saw ourselves. After the flurry of those early achievements, it might have seemed that our odyssey slowed down. The last Apollo astronauts left the moon in 1972, and no human has ventured beyond low Earth orbit since then. For decades, we confined our adventures to circling our own planet. Yet the quiet yearning to explore further never faded. We built space stations and lived continuously in orbit, learning how to survive away from Earth's surface for months at a time. Our robotic probes became our trailblazers. They ventured to Mars, to Jupiter and Saturn, even beyond the solar system, sending back breathtaking images of distant worlds. Each success, each glimpse of a far-off moon or a swirling galaxy, kept that spark of wanderlust alive. All the while, each night, the stars still beckoned, as they always have. We are made of star stuff. The iron in our blood, the calcium in our bones, were forged in ancient stars, long before our sun was born. In a sense, we are children of the cosmos, and it's only natural we feel drawn back to it. As one space pioneer observed, Earth is the cradle of humanity, but one cannot remain in the cradle forever. We have spent millennia in that cradle, gazing out. Now, slowly, we are gathering the courage and tools to climb out and explore the vastness beyond. The cosmos calls to us with a voice of wonder and mystery. We feel it when we see the Milky Way splashed across a summer sky like a river of stars. We feel it when a rocket launches, carrying our hopes beyond the clouds. It's in the goosebumps from watching astronauts float in zero gravity, or hearing our words echoed back from a robot on Mars. It is a call both scientific and spiritual, an urge to know what lies beyond the next horizon, and a yearning to connect with something larger than ourselves. Now, in the 21st century, that call is louder than ever. Our technology has advanced to a point where leaving Earth is no longer just for government astronauts in bulky white suits. More and more, everyday people, scientists, artists, teachers, tourists, dream of experiencing space firsthand. Humanity stands on the brink of a new chapter in exploration, one where space is not just a cold void visited by a brave few, but a destination that might one day feel almost familiar. The excitement of that possibility hums in the air. You can sense it when children talk about Mars as if it's a place they might actually go. You see it when new rockets launch not once in a blue moon, but every few weeks. And sometimes they return to land back on Earth, ready to fly again. We are learning how to make space travel routine, safer, and more accessible. The long-held fantasy of boarding a spacecraft as casually as an airplane is drawing closer to reality. What was once the realm of fairy tales and science fiction is gradually becoming something real and tangible. Every step into space, no matter how small, is driven by that fundamental curiosity and longing. It's the same spirit that made ancient explorers cross unknown seas. It's the same wonder that makes us stare into the night, feeling tiny and yet inspired. The universe is immense beyond our comprehension, yet here we are, fragile beings on a small planet, reaching out with our minds and machines. It's a testament to our nature. We seek to go beyond, to discover, to find our place in the cosmos. Tonight, as we drift under the stars, we are no longer content just to dream. We are answering the call. We are becoming participants in the cosmic story, not merely observers. Our journey has truly begun, moving from imagination to reality, from myth to footsteps on alien ground. And this journey, humanity's journey beyond Earth, is only in its opening chapters. Already, new pioneers are carrying the torch of exploration. Not all are career astronauts or military pilots, as in the old days. Some are private adventurers, paying their way to float in zero gravity. Some are scientists, and even tourists taking their turn in space. They suit up, climb into spacecraft, and launch skyward, just as Gagarin once did. Only now, over half a century later, leaving Earth is beginning to feel almost routine. Almost. So let us follow these new explorers as they rise on pillars of flame and break free of Earth's pull. Let us join them beyond the blue sky, into the silent ocean of space just above our world, where ordinary people are starting to become tourists in orbit. Your body is pressed into the seat as the rocket rumbles upward. For a few intense minutes, the engines roar and the crushing force of acceleration are all you know. Gravity seems to double, pinning you firmly in place. Then, suddenly, comes an almost surreal silence. The pressure eases, the roaring fades into a quiet hum. You feel a lightness in your stomach, and your limbs start to drift. You are weightless. Gingerly, you release your seat straps and find that you can float. A laugh escapes your lips as you realize you've made it to space. Through a small window above, you catch a dazzling glimpse of blue, the curve of the Earth against the blackness of the cosmos. In this moment, you are no longer an earthbound spectator. You're a traveler in orbit. As you drift closer to the window, a breathtaking panorama unfolds. The Earth lies below, enormous yet achingly delicate in appearance. Vast blue oceans swirl with white cloud ribbons. The thin shell of atmosphere hugs the planet's edge, glowing a fragile blue halo as it meets the darkness of space. In a matter of minutes, you watch day turn to night below. You witness a sunset that spreads across half a world. On the horizon, the last light of day paints the clouds gold and orange, then recedes as night claims the land. City lights blink awake across continents, sparkling like clusters of stars on the shadowed Earth. From up here, our planet is a glowing jewel of life, hanging in an infinite void. You press your face to the window, and for a long while you forget everything else. The worries and noise of daily life feel a world away, literally. There is profound quiet in orbit. Outside your spacecraft, there is no air to carry sound, so silence reigns. Inside, you hear only the soft whir of fans and your own breath. Looking down, you watch Earth roll by in serene majesty. In the span of just 90 minutes, you'll circle the entire globe. Day becomes night, and night becomes day, in a continual, breathtaking cycle. You might catch sight of the green glow of an aurora dancing over a polar region, or the flicker of thunderstorms illuminating clouds from within. It's a feast for the eyes and the soul. This is what it means to be a tourist in orbit, an experience once reserved for a select few, now slowly opening to more people. For decades, only highly trained astronauts could see what you're seeing now. But times are changing. The term space tourist might sound whimsical, but those who have gone to orbit as private citizens describe it as deeply profound. They train for months to prepare, learning to handle zero gravity, practicing emergency procedures, studying the spacecraft systems. Some are wealthy adventurers who paid their way. Others are contest winners or representatives of humanity's broader public. All of them, however, share something in common once they're up there: an overwhelming sense of awe. A few of the first space tourists visited the International Space Station, joining professional astronauts for short stays. Imagine being a guest at a home that orbits 400 kilometers above Earth. You float through its modules, eating meals while drifting around a table. You sleep in a sleeping bag tethered to the wall to keep from gently bumping around. Through a large window called the cupola, you gaze out at the ever-changing Earthscape. Each day brings 16 sunrises and sunsets. You help with simple science experiments. Maybe you're growing crystals or monitoring how plants sprout in microgravity, just as a way to contribute. You even chat with school children via video link, describing what it's like to live without gravity. For a short while, you are not just a visitor, but a resident of space. Other space tourists have taken briefer journeys, short hops to the edge of space that last only minutes. In a special rocket plane or capsule, they soar up just above the atmosphere. As the sky outside turns from blue to indigo to black, they unbuckle and float for a few exhilarating moments. They tumble and somersault, watching water droplets dance in midair like floating pearls. Out the window, the curvature of Earth is visible, a grand arc separating the blue below from the darkness beyond. Then, almost too soon, gravity pulls them back as the craft descends. These suborbital trips are like a tease of true spaceflight, a taste of the extraordinary that leaves many hungry for more. Whether it's a few minutes at the edge of space or a few days orbiting Earth, those who go tend to come back changed. Seeing our planet from above, a bright blue marble against the black void, shifts one's perspective in profound ways. Problems that felt enormous on the ground often seem smaller and more manageable when viewed in the context of Earth's thin atmosphere and lone biosphere. Many travelers report a deepened appreciation for our planet's beauty and fragility. One orbital visitor described how, from space, he could not tell where one country ended and the next began. Humanity seemed united on one world. This reflection, this overview effect, often leaves people with a renewed sense of responsibility to protect our shared home. Back in orbit, you finally pull yourself away from the window and glide through the cabin, propelled by a gentle push off the wall. Moving without gravity feels like a dream. With a mere fingertip, you can launch yourself across a room. You join your fellow travelers, who are eagerly peering out from other windows or taking photographs of the spectacle below. There's a camaraderie among you. Together, you share the quiet thrill of this experience. Some laugh with pure joy as they float upside down. Others are quietly wiping tears after their first view of Earth from space. Words often fail in the face of such beauty, so you communicate in smiles, wide-eyed expressions, and hugs that turn into slow-motion spins in mid-air. Life in orbit takes some adjustment, even for a short trip. Simple tasks require relearning. Pouring water or drinking from a cup, not possible without it floating everywhere. Instead, you use sealed pouches and straws. If you let go of an object, it will drift away. So everything from pens to toothbrushes is secured with Velcro or clips. Your body, freed from gravity's pull, stretches slightly taller. Your face puffs a bit as fluids redistribute. At first, this can cause a headache or a feeling of congestion known as space adaptation syndrome. But soon, your body finds a new equilibrium. You do a few somersaults just because you can, marveling at how gracefully you can move. It's like being an acrobat in slow motion. During your time as an orbital tourist, much of your schedule is free to soak in the experience. You spend hours by the window, taking in the world below and the stars beyond. You share meals with your crewmates, packets of food warmed and eaten with a spoon that sticks magnetically to your tray. Perhaps you even get a special treat, some fresh fruit or a favourite snack sent up from Earth, and it tastes better than ever as you float looking down on creation. At night, not that night and day have the usual meaning in orbit. You zip yourself into your sleeping bag attached to a wall or ceiling. It's all the same in 0G. Rocked by the faint vibration of the station's systems, you drift into one of the most peaceful sleeps you've ever had. This era of orbital tourism is still in its infancy, but it's progressing quickly. What was a rarity at the turn of the century is becoming more common every year. Private companies have built reusable rockets and modern spacecraft, making it possible to fly more people to space at lower cost than before. Nearly every month, another launch carries new visitors or scientific payloads beyond Earth. Each successful flight brings confidence and valuable lessons, while slowly chipping away at the price of admission. Ambitious plans are being sketched out. Perhaps space hotels in orbit, where guests can stay for a week, looking down on Earth each day. Maybe sports arenas in 0G, where you could float jump to incredible heights. Even orbital research retreats for artists and scientists to find inspiration above the world. For now, these are dreams. But the first test modules for private space stations are already under construction. Within a decade, there could be habitable orbital outposts built specifically for visitors and private crews. Orbiting Earth is a gentle first step outward. It's close enough that home is just a radio call or a short trip away, a safety net as we learn. Yet even here, we face challenges. Microgravity's effects on the body, the need for absolute reliability in life support, the dangers of space debris and radiation. With each tourist flight, we are not only giving more people a life-changing view, we're also learning how to make space travel more routine. We're learning how to live outside of Earth, if only by a few hundred kilometers. The knowledge gained will be crucial as we venture further. Eventually, every trip must end, and yours is no exception. After days that felt outside of time, the spacecraft prepares to return home. You strap into your seat once more, souvenirs and memory cards full of photos secured. The spacecraft rotates to the correct orientation, and before long, you feel the faint pull of deceleration. Re-entry begins. Out the window, the edge of the craft glows orange as superheated plasma builds up from the atmospheric friction. You feel a steady tug of gravity returning, pressing you into your seat. In a flash, the darkness of space gives way to blue sky as you streak downward. Parachutes deploy with a jolt, and soon after, there's a thump as you touch down on solid Earth or a gentle splash in the ocean. Climbing out of the capsule, you feel the weight of your body again, a strange sensation after the freedom of orbit. The ground is firm beneath your feet. You fill your lungs with fresh air and feel the breeze on your face. These simple pleasures of Earth take on new sweetness. You gaze up at the sky you just came from. It's hard to believe that only a short while ago, you were floating in that silent void, looking down. You know the memory of seeing Earth from above will stay with you forever, like a beautiful dream that was real. Space tourism is no longer a far-fetched idea. It's here and growing. For now, it remains a privilege for a relatively small number of people. But the trend is clear. Access is widening. Perhaps in the not-too-distant future, a trip to orbit could be as accessible to adventurous travelers as an exotic vacation. And someday beyond that, maybe it will be ordinary for people of all walks of life to experience the awe of space firsthand. Each pioneer who goes now is paving the way for those who will follow, helping transform space from a frontier into a familiar destination. Orbiting Earth, however wondrous, is just the beginning. It's a mere few hundred kilometers from home. Beyond lies the moon, the planets, and the wide frontier of deep space. Those who have tasted space as tourists often find themselves yearning to go farther. And indeed, humanity's grand journey is set to continue outward. The next big destination on the horizon is one we visited long ago, a world that has hung in our sky and inspired us for millennia. It's time to return to the moon. This time, not just to walk and depart, but to stay a while and learn to live on another world. Your boots sink slightly into fine, powdery dust as you take another careful step. Grey soil puffs up gently, drifting slowly in the weak gravity before settling back down. All around is a silent, stark landscape of pale rocks and deep shadows. The sky above is black and sprinkled with stars, even though the sun blazes overhead. Here on the moon, there is no air to scatter light into a blue sky. The horizon is closer and more curved than on Earth, a reminder that this world is smaller. And above that horizon, hanging in the starry blackness, is a glowing blue marble. Earth, distant yet radiant. You pause for a moment, gazing at that sight. The world where you were born now looks like a fragile jewel suspended in space. It has been over half a century since human footprints last marked this grey soil. Now, at long last, we have returned. But this time, it's not merely to visit and gather a few rocks. This time, we've come with the intent to stay longer, to learn how to live on another world. The crackle of your radio brings a familiar voice, a fellow explorer or a mission controller, checking in on you. You are part of a new generation of lunar pioneers, testing the waters for a future where humans might have homes beyond Earth. Walking on the moon feels like moving in slow motion. Each step propels you forward in a long, loping stride, and you almost bound rather than walk. The gravity here is just 1/6 of Earth's, turning every movement into a gentle bounce. Not far away, your lander stands where it touched down, its metal skin shimmering in the harsh sunlight. Nearby, an inflatable habitat module, your base camp, crouches low to the ground. Its rounded walls are partly covered with regolith, the lunar soil, that you and your crew piled up for insulation and radiation shielding. Inside that habitat is a warm, pressurized haven where you can take off your suit and live comfortably for a time. But out here, you rely entirely on your suit's life support systems. You are an explorer in one of the most extreme environments imaginable, an airless desert that has remained unchanged for millions of years. You make your way toward a gentle rise in the terrain. Each hop takes you a few meters, and with almost playful ease, you ascend the slope. At the top, you stop to take in the view. The sun casts long shadows behind you, and in the distance you see craters upon craters, their rims catching the sunlight. This pitted landscape is a record of countless meteor impacts. Somewhere not too far off is the site where, decades ago, Apollo astronauts last walked. Their footprints, their rover tracks, and the flags they left stand preserved in the vacuum, untouched by wind or rain. Thinking of those early explorers gives you a sense of connection across time. What they began, you are continuing. The next chapter in humanity's lunar story. This new mission to the moon is different in spirit from those a half-century ago. Back then, we came in a brief race and departed. Now we return in cooperation and with patience, aiming to establish a lasting foothold. Your crew is international, people from several nations working side by side. Voices with different accents mix over the radio, united by a common goal, making the moon a place where humans can live and work, not just visit. Humanity as a whole is coming back to its nearest neighbor, not planting flags in competition, but building a future together. You think of the base camp you left this morning. It's modest, just a couple of habitat modules connected by tunnels, solar panels spread out to soak up sunlight, and a small rover parked outside. But it's a start. Inside those domes, you and your crewmates have sleeping quarters and a common area where you share meals. There's even a tiny greenhouse, a clear enclosure where a few plants grow in lunar soil mixed with earth compost, under bright LED lamps. Green sprouts of lettuce and herbs, a touch of life in this barren place. They're part of experiments to see if we can cultivate food here. Every little leaf that unfurls is a triumph, proof that life can extend its reach beyond Earth. At this very moment, similar experiments are being planned and refined back on Earth. Engineers are working on designs for more permanent lunar bases, perhaps habitats buried under the soil or built into lava tubes beneath the surface for better protection. They're identifying places to find water ice, likely in the permanently shadowed craters near the moon's poles. That ice, frozen over eons, is more precious than gold here. It can be harvested and turned into drinking water, oxygen to breathe, and even hydrogen-oxygen rocket fuel. If we can live off the land by using lunar resources, a long-term stay becomes much more feasible. So, part of your mission is prospecting. One of your tasks is to set up a drill in a nearby dark crater where our instruments from orbit detected hints of water. In a very real sense, you're a miner and a scientist, helping uncover the materials that could sustain future moon dwellers. As you stand on that rise, you also imagine the future of this landscape. Years from now, perhaps lights from a larger settlement will dot the lunar night. Maybe multiple habitats connected by tunnels will form a small village on the moon. Vehicles might traverse well-worn paths between mining sites and research stations. Astronauts and scientists would live here for months, maintaining telescopes that gaze into deep space or serving as caretakers for a radio observatory on the moon's far side, free from Earth's interference. The moon could become a stepping stone, a training ground for living off Earth, close enough to reach in days if something goes wrong, but remote enough to teach us how to be self-sufficient. For now, though, your mission is relatively short. You and your teammates have been here for over a week, and you'll stay perhaps a few more days before returning to Earth. Each day is busy. Together, you set up scientific instruments to study moonquakes and monitor radiation. You collect rock samples from beneath the surface, drilling into ancient lava flows for clues to the moon's history. One of the most exciting devices you deployed is a small reactor that extracts oxygen from lunar soil by heating and electrochemical processes. When you first managed to generate a few bubbles of oxygen from moon rocks, the entire team cheered. It was the first breath of air literally made on the moon. Time on the moon has its own rhythm. Near the lunar poles where you are, the sun skims low on the horizon, providing a steady light that never fully sets. In some places at the South Pole, the sunlit peaks enjoy nearly constant daylight, which is why you chose this spot. Abundant solar energy. Yet just a short distance away, the inside of certain craters lies in perpetual shadow, temperatures plunging to unimaginably low levels, keeping ancient ice intact. This land of light and dark seems otherworldly. In the eerie lighting, where the sun's rays come in at a shallow angle, every rock and ridge casts a long, inky shadow. It is a landscape of stark contrasts, blinding brightness and pitch black side by side. Despite the harsh conditions, you find a profound beauty in this silent world. Each time you look up and see Earth, you feel a wave of emotion. You remember nights on Earth when you gazed at the moon, wondering what it was like to be there. Now you know. You're standing on that very moon, looking back at the distant Earth in your sky. It makes you appreciate both worlds deeply, the moon for its serenity and stark wonder, and the Earth for its warmth and life. Hanging in the lunar sky, Earth looks small, without borders or divisions, just a glowing whole. You feel an even stronger conviction that we all come from that one fragile place. Soon you'll have to head back to the habitat to wrap up tasks and prepare for departure. Your suit's indicators gently remind you that oxygen and battery power are finite. You linger a moment longer on that rise, taking in a panoramic view of the horizon, a horizon unlike any on Earth, marked by crater rims and an endless sprinkle of stars above. In the distance, you imagine beyond your sight the historical sites where Apollo landers still rest. You silently thank those pioneers and promise to carry their legacy forward. Back inside the habitat that evening, you and your crewmates share a rehydrated meal and talk about the day. The conversation drifts to what each of you will do when you get home. One person jokes about the long list of fresh foods they're going to eat. Another can't wait to feel rain on their face. But there's also a hint of reluctance. None of you want to leave this extraordinary place too soon. You've grown accustomed to the low gravity, the way you have to be careful pouring water, the way you hop up the ladder to your bunk. In a short time, the moon has become strangely familiar. The moon is no longer just a distant orb in the sky. It has become a place you know intimately, a place where you've lived and worked. It's humbling to realize that. You are among the lucky few to call this land home, if only briefly. Each experiment conducted, each day spent here, is a step towards a future where a lunar stay might be ordinary. Maybe one day tourists will come to experience moonwalking, or to watch an Earthrise from a lunar hotel, as the line between science fiction and reality blurs a little more with each passing year. Your time on the moon, however, is drawing to a close. The mission plan has you departing soon, lifting off in your ascent module to rendezvous with an orbiter that will take you home. There's a mixture of excitement and melancholy in the air as you and your team secure equipment and pack up samples. You decide to leave a few tokens behind, perhaps a mission patch or a small plaque to mark that you were here, another link in the chain of explorers. As you suit up for the final time, you take a mental snapshot of the habitat and the surrounding terrain, illuminated in the long lunar daylight. You know you'll carry those images in your heart forever. Climbing back into the cramped ascent vehicle and sealing the hatch, you prepare for liftoff. You strap in and press a hand against the window, looking out one last time at the grey expanse and the earth above. The engines ignite with a flash, and you feel the vehicle leap upward. Through the window, you see the ground receding and the dust you kicked up drifting back down like slow-motion snow. In moments, the lander that was your home shrinks to a dot, and the curvature of the moon comes into view. You are leaving, but you hope, truly believe, that humanity will return again and again, eventually to stay for good. As you ascend, the sky turns black again, and the brilliant sun and stars reappear. Soon, you're in lunar orbit, coasting and waiting for the command module to dock. In the quiet, you reflect on what this journey means. After so long, humans are back on the moon, and this time with new purpose. We prove to ourselves that we can live off Earth, even if just for a short while. The moon has given us confidence and taught us lessons, and it will serve as the springboard for our next giant leap. On the journey back to Earth, with the moon fading behind you, your thoughts turn to the future. The next time humans set foot on an alien world, it won't be the moon. It will likely be Mars, that beckoning red planet that has captured our imagination for so long. Everything you and your crew have done on the moon, testing habitats, using local resources, enduring the stark beauty and isolation, has been in preparation for venturing further. The lessons learned here will carry forward to Mars, where the challenges are greater, but the rewards of discovery are immense. Sitting by the window of your spacecraft, you watch Earth growing larger, a luminous blue sphere welcoming you home. Tucked somewhere in that glow is a smaller reddish dot, Mars, awaiting our arrival in the years to come. The moon may have been humanity's first off-world destination, but it will not be the last. As we leave the moon behind for now, our dreams and our trajectory set their sights on Mars, the next frontier on this grand odyssey beyond Earth. A gentle vibration rumbles through your spacecraft as the descent engines fire, fighting against Mars's gravity. After months coasting through the void, the red planet is finally below you, growing larger by the second. Outside your porthole, the sky turns a dusty gold as you slice into Mars's thin atmosphere. The capsule shudders. Parachutes deploy with a snap to slow your plunge. You glimpse the alien landscape through intermittent clouds of dust. In these final moments, your heart pounds with anticipation. Then, with a jolt and a muffled thud, you feel the craft touch down. The violent motion ceases. For a moment, silence. You've arrived on Mars. Strapped into your seat, you exhale a breath you didn't realize you were holding. Against all those kilometers, all those plans and hopes, you're now sitting on an entirely new world. The radio crackles with the voices of your crewmates and distant cheers from Earth, confirming the landing. You share relieved smiles and tears of joy with the others. There's work to do, but first comes a historic moment, opening the hatch and stepping outside. You pull on your helmet and gloves, triple-check the seals of your suit. Mars has air, but far too little oxygen and pressure to survive without protection. The capsule's hatch hisses open to a bright, strange sunlight. A ramp extends to the ground, covered in red dust blown up by the landing thrusters. Your legs tremble slightly from a mix of microgravity and nerves as you take your first steps down. Your boot presses into Martian soil, and you take a few cautious strides forward until you're clear of the lander. The ground feels firm, covered in fine grains of sand and dust that puff around your feet. You pause and look around, trying to absorb everything at once. The landscape is bathed in a warm, rust-coloured light. Under the midday sun, the sky arching above is a hazy yellow-orange, tinted by dust. Nearby, jagged rocks and boulders cast short shadows. In the distance, gentle hills roll away to meet a sky that fades toward butterscotch at the horizon. On one side, a sharp escarpment rises, the rim of an ancient crater perhaps, its outline softened by the dusty air. This world feels vast and empty, yet every rock around you whispers of a deep history. "I'm on Mars," you say softly, voice trembling with awe. Those words travel millions of kilometers back to Earth, where people rejoice to hear them. You take another step, then another, getting used to Mars's gravity, which is about 1/3 of Earth's. It's heavier than the moon's tug, but you still feel light on your feet. You could jump higher and carry more weight here than you ever could back home. You and your crewmates become the first human beings to stand on this cold desert. For a moment, you all simply gaze at the horizon, aware that you are farther from Earth than any humans before you. Blue Earth is not overhead here. In fact, it's day, and Earth won't be visible until nightfall, and then only as a bright star-like point. The realization sinks in that home is very far away now. a tiny dot across a great dark ocean of space. Task by task, you and your crew get to work setting up a foothold on Mars. Fortunately, robots and supply ships arrived ahead of you. A short walk from your lander, you find the cargo landers exactly where expected, each bearing critical pieces of your new home. Together, you unload a prefabricated habitat module from its lander, using a rover to help haul it. It's like erecting a new house in an open field, except this field is millions of kilometers from Earth. The habitat is a stout cylindrical structure with thick walls and an airlock at its entrance. Soon, with practiced teamwork, you have it deployed and pressurized. The first time you open the airlock door and step inside, you pull off your helmet and take a breath. The air is cool, clean, and entirely artificial, made by machines from tanks of oxygen brought from Earth and a little of Mars's own carbon dioxide. It has a faint metallic scent, mixed with something new, the sharp, slightly acrid smell of Martian dust that clings to your suit. It reminds you of charcoal or gunpowder. Inside the habitat, you take a moment to look around and appreciate what's been accomplished. Not long ago, this was just a blueprint and a dream. Now it's a living space on Mars. The interior is snug but efficient. There are sleeping bunks along one wall, a small galley for preparing meals, and workstations with computers and communications gear. Every surface is covered with Velcro patches, hooks, and netting to secure items in the lower gravity. You see a welcome splash of green, a small hydroponic garden unit already installed, where a few sturdy plants, kale perhaps, and little pepper plants, are growing under LED lights. These plants do more than just provide a little fresh food. They are symbols of life thriving in a place utterly barren. You gently touch a leaf and marvel that something is alive and green on the red planet. Once the immediate needs are seen to, it's time to truly explore your surroundings. Donning your suit again, you and a teammate head out on foot, while others drive a rover to set up solar panels. You walk towards a rise a few hundred meters from the landing site, where orbital images suggest interesting geology. With each step you sink slightly into the fine sand. The effort of walking in your suit, combined with the lower gravity, gives your movements a slow, bouncing quality. You feel a lightness, but also a resistance from the suit, which is bulky to keep you safe. Cresting the small hill, you come upon a shallow valley scattered with boulders. Amidst the rocks, you spot something glinting. Not metal, but an outcrop of whitish mineral deposits against the red dust. You kneel and examine it. Could it be a vein of gypsum or salt, indicating that water once flowed here ages ago? Carefully, you collect a sample and take photographs. Each evening, after hours of exploration and work, you return to the habitat, dusting off your suit before entering to avoid clogging the air filters with red grit. The sun begins to set, and you often step outside again just to watch that spectacle. The Martian sunset surprises you the first time. As the sun dips low, the sky directly around it turns a cool bluish hue, even while the rest of the sky is still copper-colored. It's the opposite of an Earth sunset. The dust in the air scatters the light differently here, making the twilight around the sun blue. You stand, mesmerized, as the small sun sinks beyond the hills, painting the sky in ethereal tones. The temperature drops rapidly. You can feel the cold through your suit. Soon, the first stars emerge. Night on Mars is darker than on Earth, because there's no large moon, only Phobos and Deimos, tiny potato-shaped moons that appear as small moving lights in the sky. When Phobos rises, it streaks across the heavens swiftly, completing its journey in just a few hours. As darkness falls on Mars, you look up at the heavens. The canopy of stars here is breathtakingly clear on a dust-free night. Amidst the constellations, one star shines a bit brighter with a bluish tint. Earth. You raise a gloved hand toward it, as if you could wave. Knowing that everyone you love, everyone who has ever lived, is on that tiny distant point of light, brings a lump to your throat. The distance is immense. At this very moment, a message you send takes many minutes to reach home. You think of the Apollo astronauts and how the moon was just a 3-day voyage from Earth. For you, Earth is more than half a year away by spacecraft. This realization both humbles and emboldens you. Humanity has dared to venture this far, and here you stand as proof that we can survive and adapt tens of millions of kilometers from our birthplace. Living on Mars is not easy. Every day is a reminder of how hostile the environment is. You monitor your life support systems constantly. Water is recycled thoroughly. The moisture from your breath and sweat, even urine, is filtered and purified until it's drinkable again. You are mindful of every resource. If a machine breaks down, you repair it with the tools and spare parts you have, since calling for new parts means waiting many months or even years. Your team is trained to handle medical issues, engineering problems, and the psychological challenges of isolation. There are moments of tension or homesickness, naturally, but the sense of purpose you all share and the wonder of being on Mars carry you through each day. A profound camaraderie forms among your crew. In the isolation of Mars, you rely on each other completely. You share not just the work, but your dreams, fears, and the awe you feel. In the evenings after dinner, maybe someone plays a soft tune on a portable keyboard or guitar, and the notes drift through the habitat's tight quarters, making you all smile. On Earth you came from different cultures, but here those differences fade. You are simply humans together on a distant world. Your mission on Mars stretches for many months. But like all missions, it has an end date. As the time to depart approaches, you have mixed feelings. You yearn for Earth, its blue skies, the feel of rain, the sound of birds, and the presence of loved ones. But you also know you will deeply miss Mars, the freedom of lower gravity, the adventure of each day's exploration, and the bond forged in your small crew. This rusty world has been your entire universe for a significant time, and leaving it will be like leaving a second home. In the final week, you pack up experiments and secure dozens of sample containers filled with Martian rocks and soil. Future scientists on Earth will pore over these, perhaps discovering new insights about Mars's history, or even biosignatures hinting at ancient life. You clean and tidy the habitat, leaving it in good condition so that it might welcome future travelers. The plan is that this equipment will be reused by the next crew, perhaps the first module of an eventual Mars base. It's strange to think you're leaving this dwelling after all the life lived inside it. You and your crewmates sign your names on a small plaque that will remain on the wall, commemorating the first people to live on Mars. When the day of departure arrives, you suit up and file back into the ascent vehicle, a rocket poised to lift you off Mars. It feels similar to when you left the moon, but now with a sense of completion and triumph. The engines ignite, and you're pressed into your seat as you rise. Out the window, you see the familiar landscape shrinking away. The site that was your home becomes just a patch of colour on the vast plain. You spot the glint of your habitat and rover one last time before they vanish from view. Within minutes, you're above the sky, in orbit around Mars. Docking with the return ship that will carry you back to Earth, you feel a rush of emotions. Mars slowly recedes beneath you, a whole planet that, for a time, was your world. You peer out one last time at the rust-colored sphere with its white polar caps and its sprawling canyon visible as a dark scar. You whisper a quiet goodbye and thank you to Mars for its lessons and its challenges. During the long journey home, you have plenty of time to reflect. Humanity has now planted its feet on two worlds beyond Earth. The moon showed we could leave our cradle. Mars is showing we can settle new lands, even if in a preliminary way. The success of this mission will ignite imaginations and plans everywhere. Perhaps within your lifetime, a permanent Mars settlement will take root, with dozens or even hundreds of people living on the red planet, building new lives under a salmon-colored sky. Perhaps children will be born on Mars one day, the first true Martians, in a sense, never having known Earth's gravity. You wonder what it would be like for them to grow up looking at a blue dot in their night sky and thinking of it as the old homeland. You also think of other frontiers that may call to us. If Mars is achievable, what about the asteroids, or the moons of the giant planets? Places like Jupiter's moon Europa, or Saturn's Titan. Could humans one day walk on those distant shores? Or perhaps we will build great cities floating in space, completely independent of any planet, with artificial gravity and gardens under vast domes. The notion that humans could live off Earth permanently, not just on one or two worlds, but wherever we choose, feels more real now than ever. Your experience on Mars is proof of concept. We can make a home for ourselves beyond Earth, even if it's small and fragile at first. When at last Earth grows from a bright star to a large shining globe outside your window, you feel a swell of excitement. Home is near. You imagine the blue skies, the rich scents of soil and rain, the embrace of loved ones. Re-entry and landing go by in a blur, and soon you take your first breath of fresh Earth air, feeling gravity pulling you back to the ground. It feels heavy and strange, but also comforting. Stepping onto Earth, the ground firm beneath your feet, you look up at the familiar sky. Somewhere out there, Mars is now the distant one. You carry Mars's dust in the treads of your boots and the red planet's mark in your soul. As you and your crew are celebrated and debriefed, you make a quiet promise to yourself. Mars was only the beginning of our life among the planets. We will return there and go further. The frontier of space is vast, and Mars has shown us that with ingenuity and determination, we can take root beyond Earth. Now the task ahead is to build on this success, to go from pioneering visits to sustained presence. Living off Earth is moving from a distant dream to something within reach. The experiences on the Moon and Mars are the stepping stones that will guide us as we prepare for the next phase, creating permanent homes in space and on other worlds, and ultimately venturing even further toward the stars. You awaken to an artificial dawn. The soft glow of simulated sunrise filters through your window, painting the room in gentle hues of gold. You stretch and feel the familiar slight lag in your limbs, a reminder that gravity here is just a bit weaker than Earth's. This isn't Earth after all. Your home is a spacious colony orbiting hundreds of kilometers above the moon, a rotating habitat that has been your abode for years. Outside your window, instead of blue sky, you see the star-speckled darkness of space and the curve of the moon's grey surface below. In the distance, Earth shines as a blue-white beacon. You find comfort in these sights. the way others might take comfort in seeing mountains or city lights from their bedroom window on Earth. You are living off Earth, and it feels almost ordinary now. You dress and walk to the colony's central park. Yes, a park in space. The habitat, a colossal rotating cylinder, creates its own gravity by spinning. The inner surface of the cylinder is your ground. As you stroll along a path lined with grass and trees, the world curves upward at the horizon, eventually arcing overhead, where, far across the cylinder, you can see the opposite side of the habitat. More parks, buildings, and tiny figures of people going about their day, all upside down from your perspective. It's a pleasantly disorienting sight that you've grown to love. Children are playing a game in a field to your left, their laughter echoing under the colony's curved sky. They bounce a ball and chase after it, their steps lighter and springier than they would be on Earth, thanks to the colony's gravity being set to about lunar level. They've never known anything else. These kids were born here. To them, this is home as naturally as Earth is to an Earthling. Passing a cluster of fruit trees, you arrive at a clear stream that runs through the park. It's part of the colony's recycled water system, engineered to create a small, babbling brook for residents to enjoy. You dip a hand in. The water is cool. If not for the graceful curve of the horizon wrapping upward and the vista of space visible through segments of the cylinder's wall, you might think you were in a park on Earth. Life in the colony has found a comfortable rhythm. There are morning markets where hydroponic farmers sell fresh fruits and vegetables they've grown in nutrient solutions under LED suns. There are cafes where people sip coffee made from beans raised perhaps in a lunar greenhouse, chatting about the day's news from Earth and Mars. A group of school children files by on a field trip, pointing at the rotating machinery at the axis of the cylinder overhead, where gravity is near zero. Factories and research labs float in microgravity, making high-tech products like perfect crystals and new medicines. Their teacher explains how the colony's ecosystem works, how plants, algae, and engineered systems loop together to keep the air fresh and the water pure. These children understand from an early age that life is an interconnected cycle, a lesson drawn from living in a closed habitat. You stop by the colony's observation deck, a platform with large windows that look out into space. A few visitors and fellow residents stand there, gazing outward. In one direction, the moon dominates the view, its craters and plains stark and bright. You can see the glint of activity down there. Near the South Pole, a cluster of lights indicates one of the major lunar settlements. That colony is mining ice and shipping water and fuel to places like your habitat. Turn the other way, and far off, Earth appears small but radiant. Occasionally, you can spot the sparkle of spacecraft traveling between worlds. A passenger ship en route to Earth, or a freighter carrying minerals from an asteroid mining outpost. Space has become a busy sea of commerce and travel, yet it's still vast enough that seeing another ship is a moment of excitement. The fact that humanity has settlements scattered like islands in the cosmic ocean fills you with quiet pride. We've become not just inhabitants of Earth, but inhabitants of the solar system. There are communities on the moon where miners and scientists live for months at a time. There's a growing city at Mars's equator, under domes and buried habitats, where families have started new lives. And there are habitats like this one, free-floating colonies, stationed at strategic points, like the Earth-Moon Lagrange points, in orbit around Mars, and even as way stations in the asteroid belt. Each is a tiny world unto itself, with people living, working, and raising children far from Mother Earth. It wasn't so long ago that living off Earth was just a daring experiment for a few astronauts. Now it's a viable, if still adventurous, life path. People move to off-world colonies for many reasons: to do research, to mine resources, to start businesses, or simply for the unique experience and hope of a better future. Communication delays mean conversations between planets can take minutes, so each colony has become somewhat self-reliant, developing its own culture and ways of doing things. Yet humanity stays connected through a network of satellites and regular transport ships. Holidays are celebrated across space. You recall last New Year's, when Earth's fireworks were streamed live to your colony, and in return, your habitat dimmed its lights to show the stars to those on Earth. Living off Earth brings challenges that required ingenuity and perseverance to overcome. This habitat's very existence depended on mastering closed-loop life support. Nothing can be wasted. Every drop of water, every exhaled breath is recycled. Food is grown in vertical farms that use minimal soil or water. Energy comes from huge solar arrays that capture sunlight and from compact fusion reactors humming softly somewhere behind the scenes. The engineering marvel of spinning a gigantic cylinder to simulate gravity still amazes you. Early pioneers in microgravity suffered bone loss and muscle atrophy before rotating habitats like this were perfected. Now, here you are, strolling under oak trees and breathing fresh air, your body healthy and strong, even though Earth's full gravity is just a memory. In making environments that nurture us off-world, we also learned better how to sustain Earth's own environment, a twofold benefit. As you continue your walk, you meet a friend headed to the transit hub, a large airlock and docking bay at one end of the cylinder. You decide to join him, since a supply ship from Earth is due, and that's always an event. The transit hub is a non-rotating section of the colony, and as you take an elevator up toward the axis, you feel gravity slip away. Soon you're weightless, floating in a broad chamber where cargo and passengers are moved in and out of arriving spacecraft. Through a window, you watch as a ship slowly approaches, shining in reflected sunlight. It's carrying not just supplies, but perhaps a few new immigrants, people who decided to leave Earth behind and try life in space. You recall your own first arrival years ago, the mix of excitement and anxiety as you left the familiar world for this new, spinning one. For the newcomers, orientation and acclimation await. Learning how to walk in lower gravity, how to live in a community where the horizon wraps around, how to handle the slight Coriolis effect that can make a thrown ball curve oddly due to the rotation. It's heartening to see that people keep coming. Our species truly is spreading outward. With each new person who adapts to life off Earth, we become a little more at home in the cosmos. You help unload some of the cargo, crates of scientific equipment, fresh books and digital archives for the library, even luxuries like coffee beans and chocolate that can't yet be produced in sufficient quantity off-world. There's joy in these small things. Everyone gathers later in the communal hall as the latest arrivals share news and stories from Earth and crack open a few treats. In the hall, a large window looks out at Earth. Together, you all raise a toast, some with glasses of recycled water wine, some with juice from colony-grown fruits, in thanks to the home planet that made all this possible, and to the future that's unfolding. That future is one where living off Earth is not a novelty, but an expanding reality. Perhaps your colony will enlarge, or spin off new cylinders when the population grows. Maybe new settlements will sprout on Europa's icy plains, or in Mercury's shadowed craters where solar power is abundant. There's even talk of one day attempting to terraform Mars, a project for generations, slowly thickening its atmosphere and spreading hardy plants to warm the surface, so liquid water could flow again. Whether or not that happens in our lifetimes, the fact remains. Humanity is learning to become multiplanetary, multi-habitat, adaptable to many environments. Of course, Earth remains our cradle and our anchor. Most humans still live on that beautiful planet, and everything we do off-world is deeply connected to it. But just as a grown child leaves home to build a life, our off-world settlements have started to develop their own independence. And with that independence comes resilience. Humanity's future is more secure when all our eggs aren't in one basket, so to speak. By living off Earth, we ensure that even if one world faces difficulties, our species and our achievements can continue elsewhere. It's a grand insurance policy for the survival of life and culture. In the colony's evening, for even in space we keep a day-night cycle for sanity's sake, you sit in your quarters and record a message for friends on Earth. You describe a day in the life of a space colonist, the mundane and the magical. You tell them about the way the sunbeam moves along the curved sky and the fun of low-G sports where you can jump 3 times your height. You mention picking apples from a tree that grows under a fusion-powered lamp, and you try to convey the profound contentment you feel. Yes, there were challenges and moments of homesickness, but overall, living off Earth has fulfilled a deep part of you that always wanted to be among the stars. You close the message with an invitation. Someday, come up for a visit. The door is always open. After sending the message, it will reach Earth in seconds over a laser link. You step outside for a final stroll under the colony's evening sky. The lights are dimmed to simulate dusk. Far above, through the transparent panels, the true night of space is visible. There, stars shine steadily without atmospheric twinkle. One of those stars is Proxima Centauri, the nearest neighbor to our sun. You find it in the sky, a tiny, indistinct point of light. Around that star we know there are planets. Once it was unimaginable that we could ever go there. But as you gaze at that distant sun, you can't help but wonder, now that humanity has learned to live off Earth, how long will it be before these stepping stones, Moon, Mars, space habitats, lead us onward to the stars themselves? With that hopeful thought, you turn in for the night, knowing that this journey is far from over. The cosmos is vast, and we are just getting started on our adventure beyond Earth. Far beyond the Moon, beyond Mars, beyond even the outer planets, a sleek ship glides through the darkness. This is a starship, humanity's boldest venture yet, a vessel bound for another sun. It silently leaves our solar system behind, carrying with it a piece of humanity to the stars. A faint glow from its engines pulses now and then, and great reflective sails catch the distant rays of our sun, boosting the ship ever faster. Inside, tucked safely in hibernation pods, a small crew sleeps. They are bound for a star system light years away, on a voyage that will last decades, perhaps a century. They embark, knowing they will not see Earth again, and that their destination lies a vast gulf of time and space ahead. How did we get here? To the point of setting sail for another star. It came step by step, over generations. The Moon, Mars, and space habitats were the training grounds, the stepping stones that taught us how to live beyond the cradle of Earth. As our presence in space grew, so did our ambitions and technology. Fast, powerful propulsion was developed to cut travel times between planets. Nuclear fusion drives, sails pushed by powerful lasers, even experiments with antimatter engines. We learned how to shield travelers from cosmic radiation, crucial for multi-year journeys. We perfected closed-loop life support to an art, creating ships that are like miniature worlds, self-sustaining ecosystems carrying humans, plants, and perhaps animals on long voyages. Each advance built on lessons learned closer to home. Perhaps most importantly, we found destinations. Over the past century, astronomers have identified thousands of exoplanets orbiting other stars. Some are tantalizingly similar to Earth, located in the habitable zones of their stars where liquid water could exist. One such world orbits Proxima Centauri, the nearest star to our Sun, just over 4 light-years away. Another promising planet circles Tau Ceti. These began as points of data in telescopes, but as technology advanced, we sent robotic probes, tiny, ultra-fast craft, to fly past and investigate up close. The first images of an alien shoreline, sent by a probe that took decades to arrive, ignited humanity's imagination anew. We saw perhaps the outline of mountains under an unfamiliar sky, or evidence of rivers carved long ago on a distant world. With hints that some of these distant planets could indeed be habitable, the question changed from, can we go, to, how can we not go? Building an interstellar ship became a project that united many of the off-world colonies on Earth. No single nation or company could do it alone. It required a civilization-wide effort. Materials were harvested from the asteroid belt and the moons of the outer planets to construct massive vessels in space, avoiding the need to launch everything from Earth's gravity well. Construction yards in high Earth orbit and around the Moon assembled components that were then ferried out to a staging area in deep space beyond Pluto, where autonomous robots and engineers pieced together the starship. Out there, the ship could be tested and finally launched without endangering any inhabited world and without needing to climb out of a gravity well. One concept for reaching the stars was the generation ship, essentially a mobile space colony, like an O'Neill cylinder with engines. Such a ship would carry hundreds or thousands of people, living full lives during a voyage that might last centuries. Those who set out might not be the ones to reach the destination. Their children or grandchildren would continue the journey, born under an artificial sky, becoming citizens of a world in transit. Another approach was to place the crew in stasis or deep sleep, so they wouldn't age on the journey. In time, technology allowed a small crew to be put into a form of suspended animation, their bodies cared for by AI systems, to be awakened when the destination was near. This method was chosen for the first starship, combined with a relatively small crew, to conserve resources. The starship leaving our solar system now is a marvel of human ingenuity. It has a magnetic shield at its bow to deflect stray atoms and dust at high speed. Its fusion engines, when periodically fired, push it to a significant fraction of light speed. Even so, the journey to the nearest star will take many long years. Time and distance in space are humbling. The crew will see the sun, our beloved Sol, shrink to just another pinpoint of light among the stars. They carry with them the cultural and scientific knowledge of humanity, libraries of books and art, perhaps DNA samples of Earth's many species, in case they have the opportunity to seed life on a new world. In a sense, that ship is a microcosm of Earth, cast into the sea of stars, hoping to take root on a distant shore. Imagine what it must be like aboard that ship when the crew eventually awakens during the voyage. They'll look out at the universe around them and see nothing but the deep night of space and the faint glow of stars. They might find our sun in the view screen, now just one star among many behind them, and feel a pang of homesickness for a world they can no longer see. But ahead, they know, a new sun is slowly growing brighter. Each year, the ship traverses trillions of kilometers, inching closer to that new frontier. The crew stays busy, exercising in rotating sections of the ship that simulate gravity, tending to hydroponic gardens for fresh food and oxygen, maintaining the ship's myriad systems. Their lives are both ordinary and extraordinary. Ordinary in their daily routines, extraordinary in their purpose, and the vast emptiness surrounding them. Back home, and by home, we now mean the entire solar system, from Earth to the far colonies. People track the starship's progress. Signals take years to cross the distance, so communication is achingly slow. Still, we know where it is by the faint beacon it sends and the occasional status update relayed by lasers or tiny courier probes. Every milestone is celebrated, leaving the heliosphere, the sun's sphere of influence, and truly entering interstellar space, for example, was cause for jubilation. It's reminiscent of the way our ancestors might have waited for an old sailing ship's letters or for the sight of a distant sail returning. Only this time, the ship may not return. This time, the ship carries our hopes to a new harbour light years away. At some point, as the starship coasts in the interstellar vastness, its crew, or perhaps an AI caretaker, decides to take one last look back. They position a camera to capture where they came from. In that photograph, the sun is just another bright star, and near it, all the worlds of our solar system, including Earth, are mere specks lost in its glare. It's a cosmic farewell portrait, the place that nurtured us, now reduced to a tiny beacon of light behind us. Humbling and poignant, our tiny pale blue dot left behind, but also thrilling, because it means we truly have become voyagers among the stars. The starship's journey is the culmination of the adventurous spirit that stirred in those early humans who first looked up at the sky. It carries forward the legacy of every explorer who ever pushed the horizon, from ocean sailors to spacefarers. And it won't be the last such journey. Even as this ship sails, plans are being laid for follow-ups. Perhaps faster vessels using breakthrough physics, or a fleet of small, smart probes to fan out to multiple stars, or even discussions of one day attempting the sci-fi dreams of warp drives or wormholes. Each generation builds on the last, turning yesterday's impossibilities into tomorrow's achievements. Back in your orbital colony, or on Earth, or wherever humans are listening to the faint updates of this interstellar voyage, there is a sense of unity and purpose. Many compare it to the first moon landing or the first footsteps on Mars, but on a vastly grander scale. Children grow up knowing that reaching other stars isn't just a story. It's something humanity is actually doing. The night sky holds new meaning. People can point at a star, perhaps that faint red one in Centaurus, and say, "We have a ship on its way there right now." That knowledge changes us, expanding how we see ourselves, not as a species confined to one world or one solar system, but as a budding interstellar civilization in the making. The journey to the stars will be long and will test the limits of our ingenuity and patience. It will unfold over many years, likely beyond a single human lifespan. But in a way, that makes it the ultimate act of optimism, planting a seed that only future generations will see fully bloom. It's a promise to the future that we believe humanity will still be around, wiser and full of wonder, ready to greet whatever might be out there on those distant worlds. We stand now on the shores of the cosmic ocean, ready at last to set sail. Our ancestors left the warmth of their first home to explore new continents. Their descendants left Earth's atmosphere to explore the solar system. And now, in our time, we commit to journeying beyond the sun's embrace. The cosmos stretches out, infinite and mysterious, full of possibilities. And here we are, tiny but courageous, answering that age-old call to adventure that began when we first looked up at the stars. It's a journey that doesn't truly end, because with each new horizon reached, another comes into view. As our first starship moves ever farther from home toward the unknown, humanity takes a collective breath, full of hope and wonder, and steps forward into the next chapter of the cosmic epic. Miles away from any familiar sunrise, morning arrives gently on Mars. In a small domed habitat, nestled amid rust-red rocks, the first faint light of day filters through a window, tinted pink by dust, suspended in the thin air. Inside, the air is warm and breathable, a tiny bubble of Earth on an alien world. A low electronic chime signals dawn, and one by one, the settlers stir from sleep. There is a hush in these early hours, an almost sacred quiet, broken only by the soft hum of air recyclers and the distant whisper of Martian wind against the habitat walls. Outside, the landscape remains frozen in pre-dawn gloom. The sky is a deep indigo, fading to maroon near the horizon, where the sun will soon appear. Even before its first rays touch the plains, the two small moons of Mars, Phobos and Deimos, can be seen briefly in the sky, pale and swift. As the settlers begin their day, one of them pauses at a window, gazing out. Out there lies a vast frontier of barren beauty. Rolling dunes and rocky hills stretch as far as the eye can see, painted in muted tones of butterscotch and rust. In the dim light, familiar constellations still glint overhead, reminders of a home now tens of millions of miles away. Earth itself is just a bright star in the western sky, twinkling with a faint blue hue. Seeing it, the settler feels both a pang of loneliness and a swell of determination. This is home now, too. This red, quiet land beneath an alien dawn. Soon, the sun's rim peaks above the horizon. Unlike the brilliant yellow-white sunrise on Earth, the Martian sunrise is softer, filtered by dust. A coppery glow spreads across the sky, and the land awakens under a sepia-tinted morning. The temperature outside is far below freezing, but inside the habitat, it is cozy and calm. The settlers move about in the gentle morning light. They prepare a simple breakfast from stored provisions and fresh greens grown in the hydroponic garden. The produce is modest, crisp lettuce, a few ripe cherry tomatoes. But these are triumphs of ingenuity, coaxed from Martian soil and recycled water under lamps that mimic the sun. As they eat, they talk quietly about the tasks ahead and share small moments of humour, forging a close camaraderie here where cooperation is survival. Everyday routines on Mars take on a new significance. Water is precious, so each sip from a cup, each drop used to nourish a plant, is appreciated. There are no long showers or running taps here. Instead, sponge baths and careful recycling of every ounce of moisture have become second nature. After breakfast, one settler tends to the water reclamation system, a network of filters and tanks that capture moisture from the air, from their breath, from every use, purifying it to be used again and again. Another checks the solar panels outside via a computer readout. Overnight, a thin layer of dust has settled on them as always, dulling their efficiency. Today, like most days, someone will need to suit up and brush them clean when the winds die down. Before stepping outside, the pioneer prepares deliberately. They don a thick, white, pressurized suit, clipping the helmet on with a reassuring hiss as it seals. The suit is bulky, but over the months, they have grown used to moving in its confines. It carries oxygen, heating, and protection. a personal spacecraft for walking on the world that offers no breathable air, where the atmospheric pressure is so low that liquid water cannot exist on the surface without boiling away. Yet within this suit, a human can step out and explore. At the airlock, there is a pause, a final check of gauges and seals. Then the outer door opens with a hiss of equalizing pressure, and red-tinged sunlight spills into the chamber. Outside on Mars, the silence is profound. The explorers' footsteps make a soft crunch in the reddish soil as they move slowly across the base's perimeter. In the weak Martian gravity, each step is almost a bounce, carrying them further than it would on Earth, as though a gentle, unseen hand were helping them along. Faint wisps of wind stir the dust, carrying it in lazy swirls around the explorers' boots. To the east, the sun lifts higher, illuminating the distant outline of ancient hills and crater rims. The sky above is a pale butterscotch colour now, with a faint hint of blue directly overhead. Although it is day, the sunlight here is only about half as strong as on Earth, enough to see clearly, but lending everything a softer, more muted look. The suited explorer makes their way to the row of solar panels set out on the ground. Fine dust coats their surface, deposited by the night wind. With a soft brush attached to their gloved hand, they methodically sweep each panel clean. It's a meditative task under the open sky. As dust is lifted, the panels glint with reflected daylight. These panels, along with a small nuclear generator humming quietly back near the habitat, power the life support systems that keep the little community alive. Every cleaned panel, every ray of sunlight collected, is another assurance that lights will stay on and air will keep flowing inside the dome when night comes. While one person works outside, others keep busy within. In a corner of the habitat, under bright grow lights, green plants climb trellises and fill trays of nutrient solution. A young botanist checks the leaves for healthy colour and measures out a carefully saved cup of water to add to the reservoir. Each plant is cherished. They provide food, yes, but also fresh oxygen and a touch of living colour in a world of reds and browns. Nearby, another settler gently tends to a set of algae tanks, bubbling quietly, part of the life support that helps regenerate air and recycle waste. There is a rhythm to these tasks, performed in unhurried calm. In another module of the growing base, an engineer runs diagnostics on the habitat's systems. Screens glow with readouts, the mixture of gases in the air, the water supply levels, battery charge, temperature, and pressure readings inside and out. Everything must be maintained within careful limits. Here, far from Earth, the margin for error is slim, but technology and human diligence work hand in hand. Satisfied that all is well for now, the engineer takes a moment to log a report to send back to Earth during the next communication window. Even though messages take many minutes to cross the void, it's comforting to share updates with colleagues and loved ones at home, to say, we are here, we are safe, and we continue our work on this distant world. By midday, the sun is high as it ever climbs in the southern Martian sky, and the land basks in a cool, pale light. Inside the dome, it is time for a short break. The explorer has finished dusting the solar panels and returns through the airlock, removing the helmet with a whoosh of air. They blink and smile as warm, humid air fogs their visor for a moment. A fellow crewmate hands them a pouch of water, and they drink gratefully, discussing what they saw outside. It's the same terrain as always, the same rocks and dunes, yet there is always something quietly awe-inspiring about it. Perhaps it's the knowledge that no human footsteps but theirs have ever marked this ground, or the way the sunlight glints off distant cliffs just so, reminding them of early morning light on red sandstone back on Earth. During lunch, The crew gathers around a small central table. Their meals are simple: rehydrated grains and proteins, spiced and warmed, and a few fresh herbs from the greenhouse to add flavor. They eat slowly, savoring each bite. There is a contentment in this routine. Each person knows their role and trusts the others with their lives. They chat about the work, about a funny moment from a transmission they received last week, or about plans for building a new storage module in the coming months. Occasionally, conversation turns to memories of Earth, the feel of rain on skin, the sound of leaves rustling in a breeze, or the comfort of the open sky and breathable air. These recollections are shared not with sadness, but with a gentle nostalgia. Each of them chose to come here, after all, and each harbours a sense of wonder that they are among the first humans to call Mars home. After lunch, work continues under the soft Martian daylight. The crew splits up to various tasks. Two of them, engineers, exit the base together to continue assembling a new section of the habitat. Over the past year, their outpost has grown from a single landing craft and inflatable shelter into a small village of connected modules. There is the main dome, living quarters, the life support and engineering bay, a science lab, storage units, and the greenhouse tunnel that snakes along one side. Today, they are adding another cylindrical module that arrived on a recent supply lander. It will become a workshop and additional sleeping quarters for future arrivals. Working in their pressurized suits, the engineers carefully guide pieces into place, securing bolts and connecting cables. They communicate with each other via radio. Their voices calm and steady, punctuating the hush of the Martian afternoon. Between their spoken words, there is only the sound of their own breathing within their helmets, and the faint thud of tools against metal, vibrations that barely carry in the thin air. As the day stretches on, one of the scientists takes a rover out a short distance from the base. The rover rolls over the sandy terrain, its electric motor whirring quietly. The scientist is going to a nearby rock outcrop that was identified from orbit, a place that might hold clues about Mars's ancient past, perhaps even signs of long-ago microbial life. Driving across Mars is a surreal experience. The horizon is closer than on Earth due to the planet's smaller size, and it feels like you could almost reach out and touch the sky. The rover kicks up little puffs of red dust as it traverses the gentle slope. Inside the pressurized cabin of the rover, the scientist is alone with their thoughts and the panoramic view. They stop at the outcrop and put on a lighter suit to step outside briefly, collecting samples of the layered rock. Each layer tells a story of a time when, maybe billions of years ago, water flowed here. Dark streaks of minerals hint at salts left by evaporated water. Holding a piece of Mars's history in gloved hands, the scientist smiles, thinking of how one day, perhaps water will flow on this world again, not just as a fleeting trickle of summer melt, but as streams and ponds under a human-tamed sky. Later in the afternoon, everyone regroups back at the habitat as the work winds down. In the thin atmosphere, heat escapes quickly once the sun lowers, and the crew can feel the chill creeping in even through their suits during the last outdoor chores. Tools are packed away, samples secured, and checks made to ensure everything is sealed up for the coming cold night. The Martian day has been full and rewarding. As the sun sinks toward the horizon, the crew gathers again by the window, or perhaps just outside the habitat in their suits for a short while, to watch the sunset. Sunset on Mars is a quietly stunning sight. The sky near the sun turns a cool blue-grey for a short time, a striking band of colour caused by the dust particles scattering the fading sunlight. Above, the rest of the sky fades to a deep amber, then to purple and black as stars emerge. They watch the sun, now a small glowing ember, dip below the horizon, casting long shadows from the habitat and rover across the ground. As darkness falls, the temperature plummets rapidly to well below freezing. The last person outside steps in and secures the airlock. Inside, lights glow softly, and the habitat becomes a haven of warmth against the alien night. Dinner is a cheerful time. Everyone is tired, but fulfilled by the day's work. They eat heartily, and then gather in the common area for a little leisure. One colonist picks up a guitar, brought all the way from Earth as a precious reminder of home, and gently strums a soothing melody. The notes mingle with the soft whoosh of the ventilators, creating a lullaby of life on Mars. Others write in their journals, or read books on tablets, their faces lit by the gentle light of screens, recording their thoughts and scientific observations, or perhaps letters to family far away. Before turning in, one by one, they take a moment to gaze out through a small, clear dome on top of the habitat designated for stargazing. The sky above Mars, free from light pollution and so thin of atmosphere, is breathtakingly full of stars. The Milky Way arches overhead in a sparkling band. Somewhere in that multitude of lights is Earth's sun, and near it, Earth itself, though too far to see directly now without a telescope. Some nights, if the timing is right, they can spot a tiny moving star that is the supply ship in orbit, or even the glint of a distant satellite. It reminds them that while they are remote, they are not entirely alone. Humanity is connected even across the void. When at last the settlers drift off to sleep, they do so with the knowledge that they have lived another precious day on Mars. It is a life of constant effort and careful attention, but also of wonder and fulfillment. On this Martian homestead, humanity has taken root beyond its birthplace, and each dawn brings new discoveries and hopes. The red planet, once a distant gleam in our sky, is now the very soil under their feet, the view outside their window, the place they call home. And as they sleep, the winds outside gently sweep over the domes and equipment, as if Mars itself were whispering a cautious welcome to these strange newcomers settling under its cold, ancient stars. On this night, as the pioneers sleep beneath the unaltered Martian sky, they dream of a day when Mars will no longer be so hostile, a day when humans might walk freely on its surface under a breathable sky. It is a bold dream, perhaps the boldest undertaking imaginable, to transform an entire planet, terraforming Mars. In the quiet darkness, with stars shining down, the idea seems as distant as those stars. But as the years pass and the outpost grows, humanity's resolve grows with it. What was once a fanciful notion begins to take shape as a plan. The first steps are small, almost humble, but they carry the weight of a grand ambition. In the decades that follow the establishment of the first Martian homestead, scientists and engineers work side by side with the settlers to begin altering the planet's icy, thin-aired state. Deep in the Martian soil lie vast quantities of frozen carbon dioxide and water ice, remnants of a warmer past. To coax Mars into giving up these resources, swarms of robotic probes are sent to the polar caps at the dawn of a new Martian spring. As sunlight returns to the poles, these machines disperse dark dust across the white expanses of dry ice and snow. The darker surface absorbs just a bit more of the sun's gentle warmth, accelerating the melt and sublimation of the ices. Slowly, gas begins to waft into the atmosphere, carbon dioxide that will thicken the air and trap more heat. It is the start of a slow, careful awakening. Above the planet, glinting in the sunlight, a great mirror unfurls in orbit like the petal of a mechanical flower. From high above, it reflects concentrated sunlight onto patches of the Martian surface that would otherwise remain frigid. These patches glow faintly under the mirror's gaze, enough to thaw permafrost and release further hidden vapors. Each year, incremental changes accumulate. The atmospheric pressure inches upward, almost imperceptibly at first, but steadily. Average temperatures creep higher. Areas near the equator that used to rarely rise above freezing now see balmier afternoons where the ground softens and ice buried beneath begins to liquefy. Back at the expanding settlements, the inhabitants notice the differences gradually. At first, it's a sensor reading, a fraction of a kilopascal more of air pressure, a degree or two warmer night temperature. Then there are small visible signs. A thin layer of frost that used to coat their solar panels each morning becomes less common. The soil, once bone dry, appears damp in places after dawn. Tiny beads of moisture from traces of humidity forming overnight. The sky, when the winds are still, takes on a slightly deeper blue tint overhead due to the growing density of the air. These are subtle changes, but meaningful. The colonists mark each milestone with quiet celebration. Each is a step toward a Mars that is alive. To further the process, human ingenuity turns to the task of creating air. At several locations across Mars, automated factories the size of shipping containers are deployed. These machines, powered by the sun and small nuclear reactors, work tirelessly day and night. They draw in the cold Martian air and use chemical reactions to produce potent greenhouse gases, exotic compounds optimized to trap heat far more effectively than carbon dioxide. Released back into the atmosphere, these gases are invisible helpers, magnifying the warmth of every ray of sunlight. Years and years of continuous operation pass, and the invisible blanket around Mars thickens. With rising heat, something extraordinary begins to happen in places. The return of liquid water. At first, it is ephemeral. During the warmest hours of the day in high summer, trickles of melted water run a few meters down dusty gullies, only to vanish into the soil or evaporate when the temperature drops. But these first trickles are harbingers. As decades of terraforming efforts accumulate, the ground ice in sheltered craters and canyons starts to melt more reliably. Small ponds form in the lowest parts of craters near the equator, lasting weeks before freezing over again. Each Martian year brings them back a little larger and lasting a little longer. The settlers find the first of these transient ponds with astonishment. In a shallow depression not far from a second colony site in the Hellas Basin, shimmering patches of water appear under the midday sun. A team ventures out in their rovers to see it up close. There, in front of them, lies a pool of water under the open sky of Mars, muddy and small, but undeniable. They remove a glove and gently dip a finger in through their suit's sampling port, feeling liquid water on Mars for the first time. Cold, but wondrous. The news sends ripples of excitement through all the Martian communities and back on Earth. It is a sign that the planet can indeed be nudged towards life. As the ices retreat and the air thickens further, clouds begin to form where once there were none. Thin, wispy clouds of water ice appear, high in the sky, tracing white streaks against the pink heavens. They are delicate and sparse at first, much like the high cirrus clouds of an Earth winter. But over time, they grow denser and more frequent. The sky gains texture. Sunsets become a riot of color as these clouds catch the sunlight, glowing gold and crimson before nightfall. With moisture in the atmosphere, the unimaginable becomes possible. Rain. The pioneers witness an historic moment one day when a dark cloud gathers over the horizon, heavy with water. The pressure and temperature have reached a threshold just enough for this to occur. At first, a few scattered droplets patter on the dusty ground, tiny dark spots appearing on the red rocks, making a soft tapping sound on a rover's metal hull. The drops evaporate almost as soon as they land, but then more follow. In a gentle drizzle, water falls from Martian skies. The settlers lift their faces upward, eyes wide behind their visors, laughing and whooping with joy as the raindrops ping off their helmets. Though they still must wear suits, they dance in the first Martian rain, a celebration of a dream made real. The air carries the scent of wet dust, an aroma not smelled on this world for perhaps millions of years. The transformation of Mars is a slow symphony conducted over generations. In the years that follow, hardy forms of life are carefully introduced to the changing environment. Scientists cultivate special strains of algae and lichens in laboratories at first, tweaking them to survive on the Martian surface. These organisms are chosen for their resilience, capable of living in extreme cold, high radiation, and thin air, while performing the vital task of producing oxygen. They start by seeding them in areas with persistent moisture, along the edges of newly formed ponds, in cracks of rocks that collect morning dew, and across the damp sand of thawing permafrost. At first, many fail. The environment is still harsh, but some cling on. Flecks of green appear on wet rocks, dark films of algae spread in shallow pools. Under the crimson daylight, these pioneers of life perform photosynthesis, turning sunlight and carbon dioxide into more organic matter and releasing tiny bubbles of oxygen into the Martian air. Decade by decade, these biological colonists multiply and slowly change the planet's complexion. Hillsides that were once bare rust begin to show shades of brown and green as lichens crust over them. Shallow basins host blooms of algae that tint the water dark, helping it absorb more heat and further warm the surroundings. Each generation of flora is engineered to be a little more ambitious than the last. Eventually, mosses and other hardy plants join the mix in sheltered valleys where air pressure has grown higher. The humans often lend nature a hand, tending outdoor plots under protective domes where young plants are grown, then gradually exposing them to the Martian outdoors as conditions improve. It is a delicate, mindful gardening of an entire planet. Time flows onward. The children of the original pioneers grow up and have children of their own, and then those children have theirs. Entire new generations live and die on Mars, each one adapting to a world slowly becoming more Earth-like. The stories of the first settlers are taught in Martian schools as legend and history, and with each generation, the fruits of those early efforts become more apparent. The atmosphere, once nearly unbreathable, has thickened significantly. By a certain point in the future, perhaps a century or two from the start of terraforming, the day finally arrives when a person can step outside on Mars with only a simple breathing mask and light jacket rather than a full pressure suit. It happens first at the lowest elevations, like the depths of Hellas Basin, where the air pressure has risen enough to be just above the threshold needed to prevent bodily fluids from boiling. On that day, a group of adventurous young Martians decide to test the new reality. Under the cautious supervision of scientists, they walk out of an airlock wearing regular clothes layered for warmth, with small portable oxygen tanks and masks covering their nose and mouth. The air is cold and thin, and they shiver slightly, but it is air. Martian air that can now support human life, even if only for a short interval. One of them removes their glove and feels the breeze on bare skin. It is chilly and dry, but gentle. Tears of joy well up as they realize they are experiencing something their grandparents only dreamed of. Standing on Mars, breathing, with a little help, under an open sky of a world becoming new. Above them, patchy clouds drift lazily. The sun feels warmer than it used to, and indeed, the desert around them is no longer the same lifeless red expanse. In the distance, a thin ribbon of water glints. A stream fed by melting snow from last winter's frost, now flowing down a shallow channel before pooling into a small lake. Around that lake, a few tufts of hardy grass wave in the breeze, the first grass to grow on Mars. The sight is humble and magnificent all at once. From orbit, Mars has changed colour in places. While much of it remains the familiar rust, swathes of dark green and brown now mark areas of flourishing lichen and vegetation along equatorial regions and newly formed ephemeral rivers. The polar caps have partly melted and shrunk, filling the atmosphere with water vapour and revealing grey rock beneath. Seasonal lakes, and perhaps even a small sea in the northern lowlands, appear as flashes of blue when conditions are right. The planet, once still and unchanging in human eyes, now has weather. White clouds swirl in the sky, occasional rain falls in some lucky regions, and the once omnipresent dust storms are tamed by moisture, their frequency and intensity diminished by the weight of a wetter atmosphere. In the growing cities and towns that started as tiny outposts, people adapt to each new development with awe. They open windows on days when the air quality is good, letting in a fresh Martian breeze where once there was only stale recycled air. They collect samples of the soil outside and find it rich with microbes engineered to prepare it for farming. In some areas, greenhouses are open to the elements, and earthling crops are tested in Martian dirt under the open sky, with varying success. Children play outside in the weak gravity, kicking around a ball in the reddish dust without a need for cumbersome suits, their laughter echoing across the valleys. They still need their oxygen masks for now, and nights remain deathly cold, but compared to the past, it is like a new world. Yet the work of terraforming is far from complete. It is an ongoing commitment that will span many more lifetimes. The air still needs far more oxygen to be truly breathable. The fledgling biosphere must be carefully managed to avoid ecological imbalance. It is a delicate art, balancing the planet's emerging climate. Enormous space mirrors continue to float in the sky, shining down, and periodic comet impacts are guided to deliver more water and gases. The people of Mars have become the custodians of an entire world's rebirth. They hold the power and responsibility to nurture a planet. On an evening decades further on, a Martian farmer, for by now there are Martian farmers, stands on the porch of a pressurized farmhouse dome in what was once the Argyre Basin, watching clouds drift across a twilight sky. He has tilled Martian soil, enriched with decades of composted plant matter, and his crops grow in the open air under protective domes that can retract on favourable days. His children chase each other outside, daring to run out for a minute without their masks just to feel the wind on their faces, before he chides them to put them back on. They giggle, their breaths puffing as mist in the cool dusk, and comply. Above, the evening star shines. Not Venus as seen from Earth, but Earth itself, glimmering on the Martian horizon at sunset. The farmer reflects on how far things have come. His own grandfather once lived in a metal habitat, dependent on machines for every breath, under a dead sky. Now, the sky is coming alive, and with it, the hopes of a new world. Mars is on its way to becoming a living, breathing sister of Earth. The road was long and remains ongoing, with centuries of effort behind and ahead. But standing on this transformed ground, one cannot help but feel the profound accomplishment. Humanity has taken a barren planet and nurtured it into bloom. What was once a silent, red desert is now dotted with patches of life and blue water, a planet in transition, wearing a tenuous but growing cloak of green. And as the Martian night comes once more, clouds gathering to perhaps shower the land by dawn, the lights of Martian towns glow warmly in the darkness. The people fall asleep dreaming not of an alien Earth, but simply of home, a home they have built with vision and patience on a world once thought forever inhospitable. The terraforming of Mars remains a work in progress, a promise to the future. But even at this halfway point, it stands as a testament to what humanity can achieve. In the grand scheme, Mars is our first act of planetary caretaking beyond Earth, the first place where we became gardeners of a new world. And with that achievement, humanity's gaze naturally turns outward again. Mars is being made cozy and familiar, bit by bit. Yet countless other raw worlds circle the sun, untouched and waiting. With Mars on the path to habitability, the next question arises: where else can life be nurtured among the stars? The answer, and the next adventure, lies further out, among the myriad smaller worlds drifting in the darkness of space. The asteroids, those ancient rocks and ice chunks left over from the birth of the solar system, beckon with untapped riches and new challenges. And so, our journey continues outward, leaving behind Mars's emerging oasis and venturing forth to the scattered stones of the asteroid belt, where another kind of frontier awaits. Farther from the sun, beyond the embrace of any planet, lies a vast archipelago of ancient rock and metal. These are the asteroids, countless fragments of primordial worlds that never were, drifting in silent orbits through the darkness. Here, between Mars and Jupiter, humanity finds its next frontier, a treasure trove of resources waiting to be harvested, and a stepping stone toward the outer solar system. The journey to an asteroid is different from the journey to a planet. There is no welcoming sky or broad landscape, no rising or setting sun on a familiar horizon. Instead, approaching an asteroid feels like approaching a lone island in space, surrounded by a sea of stars. Imagine a small mining vessel, gently closing in on a tumbling chunk of rock and ice that measures only a few hundred meters across. The asteroid's shape is irregular, pocked with craters from eons of cosmic collisions, and its gravity is so weak that a person could leap off it and never return if they weren't careful. As the vessel fires its thrusters to match the asteroid's rotation and orbital speed, the scene outside is both eerie and beautiful. Above the barren rock, the sky is black even at noon, and the sun, though distant and smaller here, shines brilliantly against the velvet dark. One can see stars, even on the sunward side of the asteroid, points of light unblinking in the void. In the distance, perhaps Mars appears as a reddish star, and farther out, Jupiter gleams with a faint yellow hue. The mining crew aboard the vessel prepares to anchor themselves to this miniature world. Two astronauts in gleaming suits float out of an airlock, tethered to their craft. In microgravity, they don't walk so much as glide, using handheld thrusters to maneuver. They gently touch down on the asteroid's surface, their boots equipped with tiny spikes and magnets to help them cling to the metallic bits in the rock. A tap of a boot sends a small spray of dust floating upward, drifting slowly in the near absence of gravity. Every motion must be slow and deliberate to avoid launching themselves inadvertently into space. With practiced ease, the astronauts secure a foothold and then begin to set up equipment. They mount a tripod drill that will bore into the asteroid's heart and deploy a web of tether lines to create a safe work area, crisscrossing the surface like the rigging of a ship on an invisible sea. This asteroid is rich in water ice mixed with rock, a precious prize. Once, such a find would be notable only for science, but now it holds the promise of air, water, and rocket fuel for the spacefaring civilization. The drill comes alive, vibrating soundlessly in the vacuum as it penetrates the surface. Chunks of regolith are excavated and fed into a small, boxy processing unit the crew brought. Inside that unit, heaters powered by the ship's solar arrays warm the material, releasing water vapor from the ice. The vapor is captured, condensed into liquid water, and purified. Some of it will be split into hydrogen and oxygen, the components of rocket fuel and also vital for life support. What was once a barren rock is now yielding resources that can sustain further journeys and colonies. As the processing continues, the astronauts take a moment to gaze around. They see the dark silhouette of their spacecraft anchored nearby, and beyond it, the endless expanse of space. There is a tranquility here, unlike anywhere else. A profound stillness, broken only by the astronauts' own breathing in their suits and the occasional murmur of radio communication. They feel a sense of connection to those early prospectors in Earth's history who ventured into wild frontiers seeking fortune. Only now the frontier is as large as the solar system itself, and fortune lies in the very stuff of life and industry embedded in these rocks. Across the asteroid belt, and among near-Earth asteroids too, many such missions unfold. Some asteroids are primarily metal, iron, nickel, even rare metals like platinum group elements, the leftover cores of protoplanets shattered long ago. Others are carbon-rich, containing complex organic molecules or heaps of frozen volatiles. Over time, the mining of asteroids evolves from small exploratory outings to large-scale operations. Swarms of automated drones join the human crews. Picture a fleet of spider-like robots scuttling over a large asteroid, perhaps one several kilometers wide. They bore into the surface at multiple points, melting ice and sorting materials. Conveyors, or magnetic rail launchers, then gently toss processed chunks of ore into space towards collection ships, taking advantage of the negligible gravity. Entire asteroids can be gradually disassembled this way, turned inside out to extract their riches. But it's done thoughtfully, with an almost surgical precision. There is no rush. In space, operations can take months or years, and patience is part of the rhythm of life out here. On one particularly large asteroid, a settlement is established, a way station for miners and travelers. They call it perhaps New Ceres or Miner's Rest, though it is not on Ceres itself, but a mid-sized rock transformed into a habitat. Engineers have burrowed into the asteroid, carving out caverns that are then sealed with metal and glass. Inside, air and warmth allow people to live without suits. On the surface, a dome has been constructed using materials extracted on site, providing an observation outpost and landing pad. From that dome, one can stand in shirt sleeves behind thick glass, looking out at the extraordinary sight of the asteroid's surface, curving away gently, with stars beyond. Because the gravity is so low, The settlement uses a slow rotation of the entire asteroid to create a bit of artificial gravity inside the caverns. A clever feat of engineering that turns the whole asteroid into a spinning habitat. Under the interior lights, green gardens sprout in hydroponic trays, offering fresh produce and a touch of life for the residents who spend months at a time in the belt. The people here are a hardy lot, with a pioneer spirit akin to the Martian settlers, but even more isolated. Still, they form close communities, sharing stories under an artificial twilight and gazing up at a ceiling painted to resemble an Earth sky, while outside, the real sky remains black and infinite. The wealth extracted from the asteroids fuels a great expansion of human activity in space. Metals for building gigantic structures, water for sustaining life and fueling ships, carbon for creating new materials. All of it is now available without needing to lift it from Earth's deep gravity well. Freighters begin to ply regular routes between the belt and the inner planets, their cargo holds filled with the makings of new worlds. Some carry water ice to parched Mars, helping to slake the thirst of a terraforming world. Others carry rare metals back to orbital factories near Earth, where they are turned into the frameworks of new space habitats and advanced spacecraft. This commerce brings prosperity and interconnection. The inner solar system and its asteroid mines become a bustling network of trade, like the shipping lanes of old, but spanning millions of kilometers through the void. Life in the asteroid belt, though far-flung, finds its own rhythm and culture. There are festivals timed to the synodic periods when Earth and the belt are closest, during which messages and maybe even passenger transports make quicker trips. Miners and explorers gather in rotating hubs, cylindrical stations at Lagrange points or in orbit around larger asteroids, to share news and relax in simulated gravity, perhaps enjoying a drink made from asteroid water and hydroponic crops, marveling at the novelty of a space-grown fruit. The conversations often revolve around the discoveries of the day, a new vein of metal found in one asteroid, or an ancient fragment of comet with pristine ice that holds clues to the solar system's origins. There is science woven into the fabric of daily work. Every core sample drilled can reveal new insights about how planets form, how life's ingredients came to Earth. The miners become inadvertent historians of the sun's family, unearthing relics of creation. Yet beyond the belt's edge, grander destinations beckon. The asteroid harvest not only provides resources, it provides practice and impetus for venturing farther. With each asteroid tamed, confidence grows to push into the realms of the giant planets and their moons. Jupiter and Saturn, with their retinues of moons large and small, await exploration and settlement. Already, scouts and probes sent ahead have been preparing the way, identifying places where outposts might safely be established, and finding sources of water and other essentials in those distant regions. And so, the focus of human adventure shifts again, moving outward to the cold moons circling those distant giants. Leaving behind the miners and their quiet, industrious world of drifting stones, we set our sights on the outer solar system. The next chapter of our journey unfolds among the moonlit skies of far-off worlds, where volcanoes of ice, seas of methane, and possibilities for life tantalize the imagination. The giant planets, Jupiter and Saturn, loom on the horizon of human exploration like distant titans, their many moons beckoning as islands in a vast, cold sea. Armed with the experience and resources gained from the asteroids, humanity ventures into the realm of these gas giants, establishing outposts on their moons, outposts that push the limits of endurance and ingenuity. Each moon is a world unto itself, with its own mysteries and challenges, and on each, small groups of pioneers learn to live in environments that range from the icy to the eerie. Approaching Jupiter, one is struck by its immense presence. The gas giant dominates its region of space, a bloated swirl of coloured clouds and raging storms. Its magnetic field traps intense radiation belts, making the space around it perilous for unshielded humans. Yet, orbiting this monster planet are intriguing moons, 4 large ones known as the Galilean moons: Io, Europa, Ganymede, and Callisto, each different, each calling explorers in their own way. To survive here, humans build habitats deep beneath surfaces or within protective shells, using water ice and lead shielding to block radiation. Perhaps the first long-term base in the Jovian system is not on fiery Io or even Europa, but on Callisto, the outermost large moon, safely distant from Jupiter's harshest radiation. On Callisto's ancient cratered plains, a habitat burrows under the ice, a sanctuary for researchers and engineers. From there, missions fan inward to the other moons. Europa, with its smooth, bright surface of cracked ice, becomes a focal point of scientific curiosity and wonder. Beneath its ice crust, a global ocean of liquid water lies in eternal darkness, warmed by tidal forces from Jupiter's gravitational pull. Here, an outpost is established on the surface, near one of the long, brownish cracks that stretch for miles across the European ice. The base is small and well insulated, hunkered down against a surface temperature of -160 degrees Celsius. When astronauts step outside in protective suits, they see a stark, alien beauty. The sky is black and filled with stars, but dominated by the enormous disk of Jupiter hanging overhead. Jupiter's banded clouds and the great red spot are faintly visible, casting a dim glow on Europa's ice. Occasionally, auroras dance around Jupiter's poles, and the light of distant lightning storms on the giant planet can be glimpsed as flickers. Working mostly in shadow to avoid direct radiation exposure, crews deploy a powerful drill that melts through the ice. It takes months, but at last it reaches the ocean below. A submersible probe is released, slipping down into Europa's hidden sea, tethered to the surface by a communications cable that glows gently in the blue light of its LED markers. In the base, a handful of scientists gather around screens, holding their breath as the submersible's cameras activate far below. They see a world no human has ever seen. Dark waters, perhaps 20 kilometers beneath the surface, illuminated by the submersible's lights. What might live here, in this alien ocean? The explorers watch in rapt silence, hearts pounding with excitement and a touch of trepidation. Maybe they catch a glimpse of something, a strange movement in the water, the hint of a translucent creature drifting past the camera, or maybe just the rugged seafloor sculpted by eons of tides. Even if life remains elusive, the knowledge that they have opened a window into a possible cradle of alien life is profound. When the crew emerges from the drill site and gazes up at Jupiter again, they feel connected to the vast cycles of nature beyond Earth, tasting the waters of another world while the storms of a gas giant churn above them. Further out from Jupiter, on Ganymede and Callisto, other outposts thrive in relative safety. Ganymede, the largest moon in the solar system, even has a thin atmosphere of oxygen and its own magnetic field. Here, under the feeble sunlight, explorers set up solar collectors and dig into soil that has been untouched for billions of years. They search for clues about Ganymede's past, perhaps discovering evidence that it too harbours a hidden ocean deep below. On the surface, the outpost on Ganymede has a view of both Jupiter in the sky and occasional eclipses as other moons cast shadows or pass in front of the sun. The residents sometimes venture out on long rover expeditions across Ganymede's mix of cratered terrain and smoother, grooved regions of ice. During rest periods, they gaze out over plains lit dimly by the distant sun and by Jupiter's reflected light. They might even spot the glow of volcanic eruptions on neighbouring Io as tiny specks against the blackness, reminders that even here, far from Earth, the solar system is dynamic and alive. Around Saturn, the scene is quieter, but no less captivating. Saturn's rings shine like a celestial jewel, a broad, shimmering disk that encircles the planet. Saturn's moons, too, become home to human outposts. Titan, with its thick orange atmosphere and lakes of liquid methane, stands out as a place uniquely suited for exploration, even for adventure. The base on Titan is unlike others in the outer solar system. Titan's dense air and mild atmospheric pressure allow astronauts to move outside with more ease. They still need warm protective suits and oxygen masks, for the cold is intense and the air unbreathable, but they do not require pressurized suits as on other moons. On Titan's surface, a crew member can walk under the dim orange daylight, surrounded by a golden haze. When they look up, they do not see Saturn directly. The clouds hide it. But the sky has an otherworldly glow. Sometimes, sunlight refracts through patches in the haze, and Saturn's presence appears as a diffuse lighter area in the sky, a ghostly halo. The outpost sits near the shore of a methane lake, its lights reflecting off the liquid surface. Standing at the edge of that frigid lake, one might see the silhouette of a small boat or submersible that the explorers use to study Titan's hydrocarbon seas. Imagine gliding across a mirror-still lake beneath a coppery sky. The only sounds the gentle lapping of liquid methane against the hull and the soft whir of the electric motor. The air is dense enough to carry sound well, and though it smells of nothing to human noses sealed in suits, the thought that this air is rich in organic molecules is thrilling. Titan's environment is a chemistry lab that could hint at alien life's building blocks. The Titan explorers sometimes do something that would be impossible anywhere else. They fly with wings strapped to their suits. In Titan's thick atmosphere and low gravity, human-powered flight becomes achievable. Using carbon fiber strap-on wings, an adventurous explorer can take a running leap and actually soar a short distance, flapping gently to stay aloft. It's more like graceful bounding than bird flight, but it is a form of flying on an alien world, and it brings childlike smiles to the crew as they experience it. After a day of work collecting samples of Titan's rich organics, mapping its shorelines, and maintaining equipment, the team returns to their habitat, where they can shed their gear and enjoy the relative comfort of an indoor environment. They gather at a window to watch as night falls. The clouds thin just enough to reveal Saturn's magnificent rings spanning the sky, with occasional lightning flashes illuminating cloud banks. It's a view that leaves them speechless each time, a reminder of the grandeur of their far-from-Earth home. Other Saturnian moons host smaller outposts as well. On Enceladus, a tiny, bright ice moon, a research station perches near the South Pole, where geysers of water erupt from cracks in the ice, forming a shimmering plume that feeds Saturn's rings. Scientists there study those geysers up close, sampling water that might originate from another subsurface ocean. At night, they stand on Enceladus's surface, where Saturn's pale globe fills the sky, and the icy spray of the geysers twinkles in the reflected light, a natural fountain of wonders. On a moon like Iapetus, with its stark two-toned coloration of bright ice on one side and dark material on the other, explorers might set up an automated station just to unravel its mysteries. Even tiny Mimas, resembling the Death Star with its huge crater, holds a beacon or two of human presence. As the years go on, these outposts on distant moons become stepping stones in their own right. They are remote, requiring month-long journeys from the inner solar system, so their inhabitants are some of the most self-sufficient people in existence. Each base is a seed of human culture planted in a far-off environment. People celebrate milestones, like the first child born in the Jupiter system, or the first wedding on Titan, marking the beginnings of communities rather than just expeditions. Yet, these moons, with all their stark beauty, remain challenging places to live. Supplies come infrequently, and the isolation is profound. To combat loneliness, communication systems bring a bit of home. Live holographic calls when the bandwidth allows, recordings of Earth's rainstorms, or the chatter of wildlife played in habitats to remind colonists of what water sounds like when it falls freely. Now and then, a supply ship or a passenger vessel arrives, bearing newcomers with fresh eyes and new dreams, and perhaps taking back to Earth some veterans ready to see their home planet again after years in the outer darkness. On a clear night, on one of these moons, say, standing outside the Callisto base, or beneath Titan's clouds before they thicken, a person can look up and see a sight, both familiar and poignant. The stars that twinkle are the same constellations known throughout human history, but from this far out, they no longer dominate the sky. Instead, one sees the planets, Jupiter, a looming colossus if you're on its moon, or Saturn's ringed elegance. And somewhere back toward the inner solar system, beyond the asteroid belt, there is a bright star that is the Sun, and near it, a tiny pale blue dot that is Earth. To the colonists here, Earth is now a distant memory, or a place only known through stories and images. They are the new natives of these distant worlds, at home under alien skies. In time, the question arises. After touching down on so many surfaces, could humanity also live in the skies of worlds where surfaces are inhospitable? Could we float in the clouds of planets themselves, or build cities drifting in the heavens of otherwise unlivable realms? Our experience with habitats in space and surviving the harshest conditions suggests that even this might be within reach. The next chapter of our cosmic journey explores this very idea. From the toxic inferno of Venus to the upper atmosphere of gas giants, and even free-floating colonies in the emptiness of space, humanity turns its creative engineering to the concept of cities in the sky, forging new homes where none could have been imagined before. Not every habitat of the future needs solid ground beneath it. Having mastered living on planets and moons, humanity turns to the skies themselves as new frontiers. If the surface is hostile, why not float above it? Why not build our homes in the air or in the void, untethered to any ground at all? From the sulphurous skies of Venus to the high clouds of Jupiter, and out to free-floating orbital colonies, the concept of cities in the sky becomes reality. These are places where human ingenuity literally hangs in mid-air, forging sanctuaries in environments once thought utterly uninhabitable. Consider Venus, Earth's twin in size, but a nightmare in environment. On its surface, lead would melt from the searing heat, and the pressure is crushing, enveloped in thick clouds of carbon dioxide and sulfuric acid. Yet, about 50 kilometers above that hellish ground, conditions become surprisingly Earth-like. The pressure is near 1 atmosphere, and temperatures are more manageable, akin to a hot summer day back on Earth. In this layer of Venus's atmosphere, humanity plants the seeds of a floating city. Vast, dirigible-like structures, filled with breathable air, buoy themselves in the dense Venusian air, for our air is a lifting gas there. From a distance, one of these floating cities looks like a cluster of enormous silvery balloons or discs, connected by a network of platforms and suspension bridges, drifting gently in the golden-hued sky. They sparkle in the sunlight that pierces the upper cloud layers. Inside one of these aerostat cities, residents live in modules hung beneath gigantic balloon envelopes. Through the windows, made of advanced materials resistant to the acidic mist outside, they gaze out at a dreamlike panorama. Above, the sky has a faint orange glow with ribbons of cloud. At their elevation, they float above the densest cloud decks, so they witness a perpetual dawn-like light. Below, an endless sea of yellow-white clouds extends as far as the eye can see, hiding the inferno ground far beneath. Occasionally, those clouds roil with subtle lightning flashes, illuminating patches of the vast cloud ocean. The city gently bobs as the air currents shift. There is a peaceful steadiness to it, like a ship on a calm sea, for the turbulent weather of Venus is mostly confined to lower altitudes. On board, life has its routines. People tend to hydroponic gardens that produce food and fresh oxygen. Scientists study the atmosphere's composition. Engineers maintain the integrity of the balloons and protective coatings that withstand the acidic environment. Children, for indeed families eventually take root even here, attend school in a central pod, learning about both Earth and their strange new home with equal wonder. They play in parks under an enclosed dome where a piece of clear sky is simulated, though they can always peek outside to see the real alien heavens beyond. Every so often, exploration craft descend on cables or in reinforced pods down towards the surface to collect samples and data. But the true home is up here, in the habitable zone of the atmosphere, sailing forever on the high winds of Venus. The concept of cities in the sky extends beyond Venus. Even the mighty gas giants could one day host human habitations in their upper atmospheres. Take Jupiter or Saturn. No solid ground exists there. Only a gradual transition from gas to liquid to dense core, and conditions quickly become extreme as you dive down. But there are levels in the upper atmosphere where temperature and pressure might allow a floating platform to survive. Picture a research station or a fuel harvesting outpost floating in Saturn's pale yellow skies. It hangs suspended beneath an immense hydrogen balloon, keeping it at an altitude where the pressure is comfortable. From the gondolas of this sky station, astronauts and scientists look out at Saturn's endless cloud bands and the sweeping vista of its rings arcing overhead like a rainbow frozen in time. They must remain cautious. Strong winds and storms occasionally buffet the station, and the engineering to keep it stable is complex. Yet the possibility of extracting valuable helium-3 fuel from the atmosphere drives this audacious venture. Imagine the surreal experience of living inside a habitat with Saturn's hazy sunrises and sunsets painting the sky, knowing that below your feet, beyond the metal hull, lie thousands of kilometers of turbulent gas. While floating outposts on Jupiter are a greater challenge due to intense gravity and storms like the Great Red Spot, one could even envision specialized robotic factories suspended in its upper atmosphere, remotely tended by humans from safer orbits or moon bases. These factories might skim the rich atmosphere for resources, all the while dangling in the intense magnetic field that crackles with radiation. Such places might not be comfortable for long-term human habitation, but they demonstrate that almost no environment is entirely out of reach for our ingenuity. Perhaps the most marvelous cities in the sky are those that are not tied to any planet at all. Freed from the bonds of gravity wells, human beings construct habitats in open space, true cities among the stars, or at least among the planets. These space colonies are the culmination of lessons learned on the Moon, Mars, and the asteroids, now applied to build self-sustaining homes in the void. One design is a rotating cylinder, miles long and capped at both ends, known as an O'Neill cylinder. Floating far from any planet, such a cylinder spins around its axis to create an imitation of gravity on its inner surface. Inside, under a curved sky, is a world made by human hands. Stand on the inner surface, and you see a landscape that wraps up and over your head in the distance. Land, lakes, and forests climbing the curving walls, until high above they meet an arching band of blue that is actually the water of a large lake held by rotation. Giant windows run along the cylinder in strips, letting in sunlight from the outside, often filtered by vast mirrors that concentrate and direct the light. The effect is a perpetual late afternoon illumination, warm and inviting. In these cylindrical colonies, tens of thousands of people could live in shirt-sleeve comfort, in a place that feels like Earth, and yet offers a view of the cosmos like no earthbound city ever could. In one such rotating habitat, imagine strolling through a small town whose street runs gently uphill due to the curve of the floor. It might be easy to forget you're in space at all. Children ride bicycles, farmers tend fields of wheat and orchards of fruit trees, and families picnic by the lakeside. And then you catch sight of something beyond the hills that no terrestrial landscape could offer. Through a transparent section of the cylinder's wall, the blackness of space is visible, speckled with stars, a reminder that this peaceful valley is actually a bubble in the void. Perhaps you see Earth in the sky as a distant blue dot, or if this colony orbits another planet, you see that planet's globe hanging stationary in the sky as the cylinder rotates. Such colonies can be located wherever is convenient, some at Lagrange points, where gravity balances allow a stable position relative to Earth and Moon, others in orbit around Mars or farther out. They are humanity's way of truly creating new worlds from scratch, tailoring gravity, climate, and day-night cycles as desired by adjusting spin and window shutters. They might have artificial suns, fusion-powered lamps, to grow crops during the dark period when the colony is in planetary shadow. In these habitats, Earth-like conditions are maintained not by the grace of nature, but by human skill and oversight. The culture of spacefaring society evolves in these free-floating cities. Some people are born who have never set foot on an actual planet. To them, the interior of a cylinder with its contained sky is home, and planets might seem bizarre in their vastness and strong gravity. Art, architecture, and lifestyles adapt. Buildings can be lightweight. People may take up hobbies like low-gravity flying with strap-on wings in the colony's microgravity recreation centers near the rotation axis, where weight is almost zero. Communities from many backgrounds on Earth mingle and create new blended traditions, celebrating the anniversary of their colony's founding, or the day it achieved full self-sufficiency, as we once celebrated harvest festivals. Through large observation decks, colonists can gather to watch cosmic events, the transit of planets across the sun, or meteor showers hitting the colony's magnetic shields, glowing like tiny fireworks. Life in these cities in the sky is life on our own terms, shaped by our needs and dreams, limited only by the resources and energy we can access. As the solar system fills with such habitats, orbiting cities around planets, drifting settlements following asteroids or comets, and cloud cities hovering over Venus or Saturn, humanity becomes truly multiplanetary and even extraplanetary. We are no longer tied to Earth or any single world. We carry our homes with us, creating bubbles of Earth-like environments wherever we go. In this expansion, we are solving countless challenges, producing ample food in space, recycling air and water perfectly, generating artificial gravity, and protecting ourselves from cosmic radiation. Each challenge met is a step towards an even more ambitious journey, one that leaps beyond the comfort of our sun's warmth. If we can make a home in the skies of Venus or the emptiness between worlds, we can dare to dream of taking that home to the stars themselves. Some of these floating cities are already being designed with engines and navigation, turning them into ships capable of crossing interstellar gulfs. The stage is set for humanity's next grand chapter, a voyage to the stars, carrying the legacy of Earth onward to new suns and new worlds beyond our own. And so, at last, humanity turns its gaze to the stellar ocean beyond our solar system. The dream of interstellar travel, once the province of only the most speculative science fiction, begins to take real shape. By now, we have built thriving colonies on planets and moons, mined asteroids, and even created free-floating cities that carry their own miniature ecosystems. We have, in a sense, already become a spacefaring civilization. The next leap is to carry our presence to another star. It is an undertaking unlike any before. Distances so vast that our minds can barely comprehend them. Journeys that span generations, and a void between stars that is dark, silent, and unforgiving. Yet, emboldened by our successes in the solar system, we set out anyway, propelled by curiosity, hope, and the age-old human urge to see what lies beyond the horizon. The first steps toward the stars are cautious. Robotic probes are sent hurtling toward neighboring star systems, tiny messengers that pave the way. Some are no larger than a hand, equipped with light sail wings that catch the push of powerful lasers or the sun's rays, sending them shooting across interstellar space at a significant fraction of light speed. These whisper-light craft streak into the dark, destined to take decades to reach even the nearest stars. They go silent as they traverse the abyss. Then one day, far in the future, we receive a faint signal, an image, a measurement, a clue from another sun's domain. Perhaps the first one sends back a blurry picture of a planet circling Proxima Centauri, our closest stellar neighbor, showing patches of green and blue. Could it be a habitable ocean world, or cloud-swirled continents? The tantalizing data ignites imaginations and fuels the resolve that we must follow in person. Constructing an interstellar ship becomes the grand engineering project of a generation. In the shadow of Jupiter, or perhaps in the safety of a distant orbit far from planetary traffic, a great vessel is assembled piece by piece. It is unlike any ship before it, a self-contained world, robust enough to sustain life for centuries. Some call it a generation ship, for those who board it will live out their lives on the voyage, and it will be their children, or grandchildren, or great-grandchildren who eventually arrive at the destination. The ship is enormous, kilometers long, a sleek fusion of spacecraft and space colony. It contains rotating habitats for gravity, powered by the glow of miniature suns in its fusion reactors. There are forests inside, and ponds stocked with fish, and wide corridors that serve as parks and meeting halls. The architecture is serene and functional, designed to recycle air, water, and nutrients indefinitely. It is a Noah's Ark of humanity and the earth life we choose to carry with us, from songbirds to fruit trees to libraries of knowledge. When standing in the heart of this vessel, one might look up and see a familiar blue sky simulated on the ceiling, the illusion occasionally parted to show the stars and remind the travellers of the cosmic voyage they undertake. The day of departure arrives. Thousands of pioneers have said tearful goodbyes to those who remain in the solar system, knowing they might never see them again, at least in person. Excitement and solemnity fill the air as final checks are completed. Perhaps the great ship departs slowly at first, using ion drives or other engines to spiral outward from the sun, then later igniting powerful fusion drives. A long, gentle push that lasts for years, steadily accelerating the vessel to fantastic speeds. On board, life begins to settle into its own rhythm. The voyagers have jobs, education, art, governance, an entire society in transit between the stars. They celebrate birthdays under artificial constellations painted on the interior dome. They grow crops under LED suns when the ship's rotation brings morning. They fall in love, have children, write music and poetry about the voyage. Looking out a window, the view is strange. The sun has become just one star among many, growing fainter with each passing year, while ahead, the destination star slowly brightens from a pinpoint to a beacon. Time becomes a relative concept on the generation ship. Years blur as the vessel crosses light years. The original crew grows old and passes on, with new generations inheriting the mission. For those born on the ship, this enclosed world is all they have ever known, a steel and garden universe drifting in an endless night. They learn about Earth and Mars and all the other places from history lessons and virtual reality archives. To them, the glowing nebulae glimpsed through observation decks or the rare sighting of a comet in the interstellar medium are more immediate than any distant planet of origin. Yet they carry Earth in their hearts, a cherished idea of a blue homeland that set them on this path. They also dream of what lies ahead, creating in their collective imagination a vision of the new world they will settle. Perhaps they even hold contests to name it, long before arrival. Will it be New Earth, Aurora, or something derived from the star's own name? It gives them a sense of purpose and continuity. Not all interstellar journeys rely on generation ships. Some concepts involve putting crews into a deep sleep, cryogenically frozen or in suspended animation, to be awakened upon arrival centuries later, having not aged a day. Others imagine advanced propulsion that could shorten the travel to mere decades or less. Antimatter engines that flare like miniature stars in the darkness, or even more exotically, warp drives that bend space itself, though these remain speculative. But the generation ship scenario is perhaps the most poignant, as it captures the essence of venturing into the unknown with no guarantees except the ones we make to each other. It is a leap of faith in slow motion, a cathedral of hope moving between suns. Through the long journey, there are moments of beauty that remind the travellers why they embarked. When the ship passes through the outer reaches of another solar system, they might see the remote glimmer of that star's Oort cloud comets, or witness a supernova's distant flash painting the sky, events that no human has seen up close before. In quieter times, an observer can float in a windowed chamber at the ship's rotating hub, where gravity is near zero, and simply watch the stars. Without a sun dominating the view, the Milky Way is a jeweled tapestry from horizon to horizon, a constant companion on the voyage. Imagine a child pressing their face to the glass in such a chamber, seeing countless stars, and asking their parent which one is the new sun they are headed toward, and which one was the sun they left behind. These personal moments, as intimate as a family conversation, occur against the grandest backdrop of all, interstellar space. After a long time, perhaps many decades or even centuries, the destination draws near. The star that was once a point of light is now a brilliant sun filling their view. The ship begins its deceleration, a reversal of the long acceleration, slowing down to be captured by the star's gravity. Everyone aboard feels a thrill of anticipation and nervousness. What will they find? Will the world they hoped for be there? And will it be habitable? Telescopes aboard the ship and earlier probe data have long confirmed the existence of a promising planet, one with oceans and clouds, maybe even green continents. They have studied its atmosphere from afar, finding signs that hint it could be welcoming. Perhaps even lights glimmer on its night side, though that might be just their imagination or a natural phenomenon. With each passing day, the planet grows from a speck to a disk. Continents, swirling storms, the sparkle of polar ice caps become visible. It is real. It is there, waiting. The final approach is carefully orchestrated. The great ship parks in orbit around the new world as smaller landers begin ferrying people and supplies down to the surface. Those first footsteps on this alien soil are taken with reverence and joy. A new world has been added to the realm of humanity. The travelers find themselves under an alien sun, breathing air that no human has ever breathed, feeling new gravity beneath their feet. Perhaps the air is a little different, the gravity a bit lighter or heavier than Earth's, the sky tinted a different shade. Yet, there are familiar elements: the warmth of sunlight, the whisper of wind in the alien trees, if there are trees, or the lapping of waves on an untouched shore. Emotions run high. Some laugh, some weep, some stand in awed silence. They plant a flag, or perhaps a garden, symbolic of starting life anew. They send a message back to those listening across the light years. We are here. Humanity has arrived in a new world. That signal, travelling at light speed, will take years to reach the solar system, but when it does, a wave of celebration will sweep across all of humanity's scattered settlements. We will all share in the triumph of our species, stepping beyond its star of origin. As the new colonists begin to explore their surroundings, setting up shelters, and beginning to learn the ways of this strange and wonderful planet, they carry with them the collective knowledge and spirit of Earth. In their new night sky, their old sun is just another star, a tiny pinpoint, perhaps known only by its position on star charts. And around that distant star, far away, our home solar system continues to thrive, full of people living on worlds and habitats we have imagined. Humanity is now, truly, a galactic traveller in the making, having crossed the interstellar gulf. This is not an ending, but a beginning of something new. The voyage to the stars is the ultimate journey, one that doesn't end with one landing or one new world. It opens up an infinite frontier with countless stars and countless possibilities. Each new sun we reach could become the centre of another blossoming of life and culture. And as we stand on that first alien shore, under unfamiliar constellations, we know that we carry the legacy of every dream, every daring step, every sleepless night, gazing at the sky that came before. From the first campfires of ancient humans, staring up in wonder, to the settlements on Mars, to the floating cities in clouds. All of it led us here, and it will lead us onward, ever onward. Now, having ventured across the cosmos in our imagination, from a humble homestead on Mars to the soil of an alien world under another sun, we pause to reflect on how far we have come. The story of humanity beyond Earth is still only in its opening chapters. There is much left to unfold, many questions to answer, and new fantasies waiting to become reality. Our journey is far from over. In fact, it feels like it's only just beginning. With hearts full of wonder and determination, we turn our eyes toward the unknown frontiers that lie ahead. The cosmic ocean stretches out before us, infinite and beckoning, and we are ready to continue our odyssey among the stars. The next great frontier of our journey may not lie outward, but inward. As we venture deeper into space and time, we will inevitably turn our ingenuity toward ourselves, reshaping life to survive and thrive beyond Earth's nurturing cradle. In the vacuum of space, in the strange environments of alien worlds, and over the immense durations of interstellar voyages, humanity will be tested in ways our ancestors never faced. To meet those challenges, future humans might have to transcend some of the biological limits that bound us to Earth. This is the essence of life unchained, life set free from the constraints of its original form and habitat. Space is beautiful, but it is also harsh. Even a short distance from Earth, in the weightlessness of orbit, our bodies begin to change. Astronauts lose bone density and muscle over time. Their immune systems weaken, fluids shift strangely in their bodies, and cosmic radiation peppers their cells with DNA damage. These are just hints of the greater obstacles awaiting us on longer journeys. If a person were to spend years traveling between the stars, how would their body cope? And if generations are born and raised in low gravity or artificial habitats, what new traits might they need? One avenue of adaptation is technology worn or implanted in the body. We already use spacesuits as second skins to protect us. Future explorers might use advanced suits or even built-in augmentations. Imagine explorers with enhanced vision that can see beyond the usual spectrum, aided by ocular implants to spot otherwise invisible cosmic rays or infrared signs of life on a dim planet. They might have biosynthetic blood that carries oxygen more efficiently, helping them endure emergencies or extended stays in thin atmospheres. Perhaps they'll wear exoskeleton frames not just to lift heavy equipment, but to simulate gravity on their bodies and prevent muscle loss. Over time, these enhancements could become as natural to humanity as wearing clothes or glasses, extensions of ourselves that keep us safe in environments where our naked biology would falter. Even more profound is the possibility of altering our very genetics. With tools like advanced gene editing, future scientists could tweak the human genome to better suit space. Consider radiation. On a months-long voyage outside Earth's magnetic field, the cumulative exposure can be significant. Some small Earth creatures, like the tardigrade, a microscopic water bear, can survive extreme radiation and even the vacuum of space by entering a cryptobiotic state. While humans can't do that, researchers have pondered if certain tardigrade genes or other protective mechanisms could be introduced into human cells to improve DNA repair or radiation resistance. It's a radical idea, but not beyond imagination. A future astronaut, carrying a snippet of tardigrade-inspired code in her DNA, might shrug off doses of cosmic rays that would make an unmodified person ill. We might also engineer ourselves for stronger bones and muscles that don't deteriorate as easily without gravity's pull, or adjust our inner ear balance systems to avoid space motion sickness. Beyond physical robustness, life unchained could mean freeing ourselves from the strictures of time and aging. The distances between stars are vast. Even a journey to the nearest could take decades, with near-future technology. If explorers must remain in good health for decades or centuries, slowing down the aging process or inducing suspended animation might become key. Scientists today are studying the genetics of aging, and one distant goal is to greatly extend human health span. In a future where that research comes to fruition, we might see crew members on an interstellar voyage undergo therapies that allow them to remain youthful and vigorous for the duration. Alternatively, there's the idea of stasis, placing humans in a deep sleep or hibernation-like state for long journeys, much as science fiction often envisions. This might involve cooling the body and reducing its metabolism to a trickle, so that subjective months pass while objectively decades go by. Waking up near a new star, the crew would hardly have aged a day since departure, effectively leaping across time as well as space. But adapting life is not just about the travelers, it's also about the settlers and their children. When we establish habitats on the Moon, Mars, or distant exoplanets, those born and raised there will live under conditions unlike any on Earth. Consider a child of Mars. Growing up in 1/3 of Earth's gravity, she might become taller and more slender than she would have on Earth, as her spine elongates and her heart doesn't have to work as hard to pump blood upward. Over generations, if people remain isolated on Mars, or any colony with lower gravity, natural selection or deliberate genetic guidance might lead to a population subtly different in physique, Martians in a true sense. Similarly, on a planet with higher gravity, children might grow slightly shorter and more muscular, evolution favoring stocky builds that handle the weight better. These changes could occur gradually, an unplanned evolution. Or humanity might guide the process intentionally, using genetic knowledge to ensure that colonists' offspring have traits best suited for their new world from the moment they are born. We might even shape new senses or abilities in ourselves. On a dark world, far from a bright sun, human eyes could be enhanced to see in very low light, perhaps by incorporating genes from deep-sea creatures or using nanotech retinal implants. On a world with multiple suns, where night never fully falls, humans there might adopt altered sleep patterns or evolve new ways to protect from perpetual sunlight. If a colony is established in the oceans of an icy moon, maybe its people will embrace modifications that let them hold their breath for hours, or even include artificial gills to extract oxygen from water, freeing them from the need for surface air. In each case, life once confined to one set of conditions finds a way to bloom in another. The concept of life unchained also extends to how we reproduce and sustain communities in space. Traditional human reproduction could face challenges under low gravity. Everything from conception to gestation might work differently without Earth's pull. In anticipation, scientists might develop artificial wombs that can nurture embryos in space, or special rotating habitats that provide areas of simulated gravity so that the first generation of spaceborne humans develops normally. It's conceivable that early settlers of a new planet will carry frozen embryos or gene banks, not only of humans, but of animals and plants, essentially bringing the seeds of an entire ecosystem. In this way, Earth's life becomes unchained from Earth itself, ready to blossom on distant worlds when conditions are right. A barren planet could, over decades and centuries, be introduced to hearty microorganisms, then to adapted plants and insects, gradually building up a biosphere in which future children might run and play under an alien sky. One of the most transformative prospects is merging our biology with machines, not just wearing gadgets, but truly integrating with technology. The line between human and artificial intelligence could blur. Already, we use computers to augment our thinking and mechanical implants to restore lost function. Future humans might take this further by installing neural interfaces that allow direct communication between mind and computer. An explorer on a starship might have a cognitive implant linking her thoughts to the ship's AI, giving her instantaneous access to calculations or data that would have taken her brain alone much longer to process, effectively unchaining her mind from the limits of solo human memory and speed. In daily life, on a space habitat, people might use brain-computer links to communicate almost telepathically via encrypted signals, talking across the colony without speaking aloud, creating a sense of group consciousness at will. From there, it's a small conceptual step to the idea of uploading consciousness entirely. If one could map a human brain in exquisite detail and emulate it in software, a person's mind could, in theory, be transferred to a more durable, non-biological form. Though this remains speculative, consider the potential for space travel. A human mind housed in a synthetic body, perhaps a humanoid robotic frame, or something even more abstract, that does not need air, food, or protection from radiation. Such a being could endure journeys and environments that flesh and blood humans never could. They might be sent ahead as envoys to distant stars, to prepare habitats for organic humans who arrive later. Or they might become the primary inhabitants of space, representing a new phase of human existence. The philosophical questions are profound. Would an uploaded mind truly be you, or simply a copy with your memories? But if the technology became available, some might eagerly volunteer, especially if it meant effectively living for millennia and witnessing cosmic wonders firsthand that mortal humans could only imagine. In parallel with enhancing ourselves, we will harness biology in broader ways. We may engineer plants to grow in alien soils, or even without soil. Imagine crops tailored to thrive in Martian dust, or algae tweaked to flourish in the subsurface ocean of Europa and produce oxygen. We could design microbes to terraform environments, hardy bacteria that consume toxic atmospheres and excrete breathable air, or fungi that break down tough regolith into fertile soil. This is life unchained at the ecosystem level. Earth's life forms breaking free of Earth and becoming a toolkit to spread life to other spheres. In doing so, humanity becomes not just an explorer, but a gardener of worlds, carrying the essence of Earth's biosphere to places that have none. Of course, altering life, whether ourselves or other species, raises deep ethical questions. What does it mean to be human if we start changing our fundamental biology? There will likely be debate and differences. Some individuals or cultures may embrace becoming cyborgs or gene-edited superhumans, while others might choose to remain as unmodified as possible, treasuring the original human form. It's easy to envision a future where multiple branches of humanity coexist. Baseline humans who are much like people today, genetically enhanced humans with new immunities or physical capabilities, cybernetic humans with significant machine augmentations, and digital minds that have shed a permanent body altogether. Will they all recognize each other as kin? Ideally, yes, bound by shared heritage and mutual respect. But ensuring that could be a challenge. Our descendants will need to cultivate a strong sense of identity that isn't tied just to appearance or biology. Perhaps they'll coin a new term for this expanded family of intelligent beings that goes beyond human, a word that acknowledges personhood in many forms. There is hope that by transcending our limits, we might also transcend some of our old prejudices and fears. A mind that can live for centuries may take a longer, more patient view of conflicts. Communities where people can dramatically alter themselves might learn profound lessons about acceptance. When your neighbor could one day swap their biological arm for a bionic one, or adapt themselves to breathe underwater, you learn to see the person beneath the surface changes, Space settlements, by necessity, might foster a culture of radical openness to difference, because survival could depend on many types of skills and adaptations working together. In a domed city on a far-off planet, the doctor might be an AI, the engineer a cyborg, the farmer a genetically enhanced agronomist who can tolerate high radiation, and the teacher an unmodified human tying everyone together with shared stories and history. Each would have to appreciate the other's contribution for the community to thrive. Life unchained also implies responsibility unchained. In freeing ourselves to play with biology and evolution, we take on the weight of guiding those changes wisely. If we release engineered microbes to terraform a planet, we must ensure they don't become a blight or spread uncontrollably. If we create new subspecies of humans tailored to different worlds, we must grant them the same rights and dignity as any other human, and not see them as experiments or tools. The best future is one where these powerful technologies are governed by wisdom and compassion, where our goal is to uplift and protect, never to dominate or harm. Imagine a future scene to bring these ideas to life. On a starship bound for a distant star, a diverse crew works together. One crew member is a cybernetically augmented pilot, her reflexes sharpened by an AI coprocessor embedded in her nervous system, allowing her to navigate hazards at near light speeds with ease. Another is a biologist who, thanks to genetic treatments begun before he was born, can function on very little sleep and withstand high radiation. Crucial traits for tending the ship's garden and monitoring life support during solar flares. In the medical bay, there are cloning vats growing patches of tissue and even entire organs. If someone is injured, fresh skin or a replacement organ can be grown on site, freeing the crew from reliance on Earth-based supplies. There's also an android on board, carrying the uploaded consciousness of a veteran engineer. In day-to-day life, this digital person converses with the rest of the crew, cracks jokes, offers advice drawn from decades of experience, and even says she feels excitement as the ship approaches its destination. Her feelings might be algorithms, but they are sincere. Each member of this crew is different in form and ability, yet they gather together for meals in the galley. The android doesn't eat, but sits with the group, charging her energy cells while sharing in the conversation. They swap stories and dreams. In their camaraderie, one can see that humanity has grown to encompass all of them, flesh and blood, augmented and artificial alike, without losing the warmth of connection. Back on Earth, or perhaps on a future Earth-like colony world, ordinary people benefit from the innovations driven by the needs of space. A grandmother receives gene therapy that was originally developed to prevent muscle loss in astronauts. Now it keeps her bones and muscles strong in old age, extending her healthy, active years. A child born with a congenital illness is cured by a precise genetic edit, a technique first perfected to help settlers on Mars resist a toxic element in the soil, now used to eliminate a hereditary disease. Workers constructing a new habitat wear powered exosuits derived from space designs, enabling them to lift heavy materials safely and work long hours without injury. Even those who never leave their home planet might have subtle enhancements, nanoparticles in their bloodstream that neutralize viruses, an offshoot of research into maintaining astronaut health in closed environments, or a communication implant that keeps them connected to a planetary network with just a thought. In these ways, the advances we make to survive beyond Earth end up improving life on Earth and other settled worlds as well, unchaining humanity as a whole from many limitations that once caused suffering. As life unchained unfolds over generations, we may witness the rise of entirely new forms of life that nonetheless trace their origin to us. If we create self-sufficient colonies of human-machine hybrids, or societies of uploaded minds. At some point, they may diverge and evolve along their own paths. Perhaps a colony of digital beings on a distant computer network, orbiting quietly around a star, will begin to modify their own code, growing ever more intelligent and abstract in their thoughts, thinking thousands of times faster than an organic brain, communicating in pulses of light and ideas far removed from human language. In time, they might consider themselves a distinct species, though one that remembers humans as their creators or ancestors, much as we think of the single-celled organisms from which all complex life arose. Likewise, those who choose a fully biological but heavily modified route imagine a population that settles a world mostly ocean and, over centuries, adapts so fully to aquatic life that they develop webbed limbs, larger lungs, or even symbiotic gills. They might eventually become so different from baseline humans that they could be considered a new species of human. Homo aquaticus, perhaps. They would no longer interbreed easily with Earth humans without technological intervention, but they would carry forward human culture in their own unique way under the sea. The family tree of humanity could branch outward, radiating into a whole genus, or even a family of intelligent species, spread across planets and habitats. Far in the future, someone might attend a grand assembly on some galactic hub and see beings of many kinds gathered, some tall and humanoid, some living metal and circuitry, others perhaps in swirling forms of light within protective containers, minds that live as energy. It would be a scene out of the wildest imagination of our present day, yet all those diverse entities could be descendants of humanity's ingenuity, directly or indirectly. How far our definition of us will have expanded. It's a breathtaking thought that from the single-species society we are now, could grow a rich diaspora of intelligent life, all originating from Earth, but now adapted to every corner of the galaxy. If we handle this future wisely, that blossoming of diversity will be a source of strength and wonder, not conflict. Each type of being will contribute its strengths to the tapestry of civilization. The digital minds might share vast knowledge and run complex calculations to guide policy and science. The biologically adapted might have unique insights into living harmoniously with extreme environments, teaching others what they've learned. The hybrids could act as intermediaries, ensuring everyone remains connected in understanding. Our collective understanding of consciousness and life will deepen as we come to know these different modes of existence. We might finally answer questions like, what parts of our humanity are fundamental, and which parts were merely due to the particular bodies we once lived in? Perhaps empathy, curiosity, creativity, and love will prove to be universal constants, traits that persist, whether one is made of flesh, silicon, or something else, so long as minds are shaped with care and compassion. Life unchained, at its best, means the core of what is precious about life, its capacity to experience, to grow, to care, is no longer chained to one planet or one form. It can express itself in myriad forms across the cosmos, each one a new verse of a grand song. As we contemplate such transformations, there's a reassuring thought. Though the vessels we sail in, our bodies, our minds, may change, the ocean of space remains the same vast mystery that called to our ancestors. The more we adapt, the more of it we can explore and appreciate. The human story becomes the story of life itself, awakening to the universe in as many ways as possible. One day, if we meet other intelligent species among the stars, beings who arose entirely independent of us, we might find them utterly alien in appearance and thought. Yet, through our own journey of internal diversification, we may be uniquely prepared to accept and befriend them. Having long practiced the art of recognizing intelligence and personhood in forms very different from our original one. In this way, life unchained is both a liberation and a preparation. We liberate ourselves from old limits, the short lifespan, the fragile body, the singular perspective. And by doing so, we prepare for the broader destiny of living in a universe of endless variety and challenge. Step by step, modification by modification, we turn what once were fantasies into realities, breathing underwater, walking in open space without fear, communicating mind to mind across distances, even touching the very code of life and sculpting it thoughtfully. All of this might sound daunting, even disorienting, to us who are still very much creatures of Earth. Change often is. But it's worth remembering that humanity has been slowly unbinding itself for a long time. We have always used technology to extend our limbs and senses. The ship extends our legs across the sea. The telescope extends our eyes to the stars. Medicine extends our lives beyond their natural span. The changes to come are on a larger scale, yes, but they follow a path we started long ago, when we first shaped tools and dreamed of being more than we are. The key will be carrying our values with us into this brave new realm. Honor, empathy, love. These must remain our guiding stars, even when the forms we take are novel. Picture a distant future classroom, perhaps a virtual learning space where biological and digital students alike participate. They learn about ancient Earth and the early humans. Maybe they recreate what it was like in the 21st century, beings bound to one planet, with modest lifespans and simple rockets, gazing at the heavens with big dreams. They might smile at our era's limitations, but also feel gratitude. Without those early dreamers and explorers, without those first people who dared to modify a gene or test a neural link, life could never have broken free in all the ways it has for them. In their own faces, whether those faces have warm flesh, metallic plating, or something entirely abstract, they carry the legacy of human determination to grow and explore. Ultimately, life unchained is life empowered, empowered to wander, to endure, to imagine beyond previous limits. And as we look outward once more, we can consider how these transformed pioneers might knit together new societies on a galactic scale, forming a community that spans the stars. In the quiet reaches of space, humanity's journey continues onward. We have ventured beyond our familiar cradle, adapting to new worlds and new realities. As we wander among the stars, the bonds that tie us together begin to stretch across light years. Still, we remain connected by the shared dream that propelled us off Earth in the first place. Our civilization, once confined to a single pale blue dot, is becoming something new. A community scattered among many worlds, yet linked by history, culture, and hope. Far from Earth, on a colony beneath the glow of an alien sun, a group of settlers looks up at a sky with unfamiliar constellations. They build homes and lives on a planet that was once only a distant speck in our telescopes. Over the years, this colony has grown into a thriving town. Children play under the light of two moons, and farmers tend to strange crops in reddish soil. In the town square, there is a monument, a small, worn globe of Earth, brought by the first pioneers as a reminder of where they came from. Underneath, an inscription reads, "For all humankind, our journey continues." This simple statue represents a heritage shared across the cosmos, a thread connecting that far-off settlement back to Earth and to every other human outpost in between. As more of these settlements take root on distant planets, humanity blossoms into a galactic society. We can imagine a network of communication stretching between star systems, beams of light carrying messages, greetings, and knowledge from one world to another. These signals travel immense distances, sometimes taking years to arrive, yet they keep the flame of unity alive. A researcher on a planet orbiting a distant star sends her latest findings to colleagues on Earth, knowing that her message won't be seen by human eyes until long after she's gone to sleep under an alien sky. Weeks or months later, on Earth, a reply arrives, perhaps simple words of encouragement, bridging the void. In this way, across the silence of space, a dialogue persists. It is slow and patient, echoing the old days of letters carried by ships across oceans, but it endures. Though communication is slow, travel is slower still. A voyage between stars might take decades even with advanced propulsion, unless some faster-than-light breakthrough is achieved. As a result, face-to-face encounters between people of different star systems remain special events. A visitor from a far colony is greeted with excitement and hospitality. People gather to hear her tales. She describes the twin suns of her home sky, or brings delicacies made from alien crops to share. In her eyes, the locals see a reflection of their distant kin, and in her voice, the echoes of another world. Such meetings remind everyone that even separated by light years, we share a common story and origin. One can imagine two friends or siblings separated by interstellar distance. One remains on Earth, while the other has made a home on a planet orbiting another star. They exchange messages that take years in transit. A simple, "Hello, I'm thinking of you," sent from Earth arrives when the one on that far world has celebrated several birthdays. She replies with photographs of her new home's coppery skies and twin moons, images which reach Earth long after those moons have shifted in her sky. Yet despite the delay, the correspondence continues throughout their lives. Each message is cherished, a reminder that love and kinship persist across any distance. In those moments of reading a letter from a far-off loved one, the vast emptiness between stars feels just a little less cold. On each new world, society evolves in its own unique way. The people of one colony live under a dim red dwarf sun, where days are bathed in perpetual twilight, and the vegetation has adapted to the faint ruby glow. Their clocks and calendars have adjusted to the slow, lazy orbit that gives them years much longer than those on Earth. They celebrate festivals when their small moon eclipses their star, plunging the sky into an even deeper crimson night. Meanwhile, on another world orbiting a bright sun-like star, the inhabitants experience short, vivid days and a gravity slightly stronger than Earth's. Generations born there grow up sturdy and compact. Their movements are a touch slower and more deliberate under the heavier pull of their planet. Their dialect, their traditions, even the way they dance under unfamiliar constellations, diverge from those of their ancestors on Earth, reflecting the new rhythm of life their world demands. Not all settlements are on Earth-like planets either. Imagine a colony on a moon orbiting a giant ringed planet. In its sky, the gas giant looms large and splendid, adorned with broad rings that glitter in sunlight. The moon's day-night cycle is punctuated by eclipses, when the massive planet periodically blots out the sun, bathing the moon's landscape in a twilight tinted by the planet's colours. People there mark time not only by the rising and setting of their sun, but by the majestic transit of their ringed planet overhead. Their art might be filled with swirling motifs inspired by the bands and rings of the gas giant. In another place, humans live entirely in artificial habitats, rotating cylindrical colonies where towns and forests line the inner curve of a great metal drum, and outside is a view of the stars through a transparent dome. For these spacefaring folk, sunrise comes when the habitat's lights brighten and night when they dim. Constellations are something you visit at an observatory. Each colony, whether on a planet, moon, or free-floating station, develops its own culture and identity as rich as any on old Earth, each moulded by the environment and circumstances of a world light years away. Yet for all these differences, they remember they are human. They know that in ages past, all humans lived on one small world, under one sun. In schools on these distant planets, children learn about Earth, the cradle of humanity, much as children on Earth learn of ancient Mesopotamia or the Indus Valley. To them, Earth is part history, part legend, a real place of blue oceans and diverse life, documented in libraries and archives, yet almost mythical in its distance. Some may daydream of visiting that distant mother world, though they know it would be a voyage of many years. Perhaps a few pilgrims do make the journey, setting foot on Earth as we might visit a sacred ancestral homeland. When travellers from the stars return to Earth, they often find it at once familiar and astonishing. A visitor from a dim, arid colony might be overwhelmed by Earth's thick atmosphere and riotous greenery. She stands in awe of a thunderstorm pouring life-giving rain, marvels at snowflakes if her home world never knew such cold. Walking through a city on Earth, she sees monuments and museums that preserve humanity's long journey, from the first stone tools to the rockets that opened the space frontier. She strolls through an ancient forest, breathing deeply of air rich with the scent of humus and growth, feeling the gentle gravity her bones were shaped for. Many such visitors collect mementos, a book of earth poetry, a vial of ocean water, a pressed leaf from an oak tree. Back on their home planets, these treasures are shown to friends and children as tangible links to the fabled planet of origin. Communication alone cannot bridge every gap. After many generations, a colony might become self-sufficient and even forgetful of its origins if contact wanes. To guard against that, humanity might establish traditions to keep our galactic family connected, perhaps every so often, say once a century. Representatives from each settled world gather on a single planet or a great space station to share stories and renew their bonds. It could be a grand festival of worlds where travelers arrive by starship bearing artifacts, music, and cuisine from their home skies. Under a vast, domed pavilion, delegates from dozens of star systems exchange gifts. A vial of water from Earth's oceans might be offered to a desert world. In return, Earth's envoy receives a packet of hardy seeds cultivated under the red rays of another sun. People dine together on a mosaic of foods, fruits from alien orchards alongside bread baked from earth-grown wheat. As night falls, they step outside to view the stars, knowing that people from each of those stars' planets are gathered here with them. At such a gathering, stories and songs become the universal language. Dancers from a low-gravity planet perform graceful leaps that leave onlookers breathless. A choir from Earth sings an old melody about the first voyages into space, bringing tears to the eyes of those from far-off colonies who learned the song from their grandparents as a lullaby. Around communal fires, or their futuristic equivalent, travelers swap tales of home. Laughter and understanding flow despite differences in slang or custom. Through these cultural exchanges, everyone realizes that while their habits and accents differ, the core of their humanity, curiosity, creativity, love of life, is shared. When the festival ends, the attendees depart for their distant homes, carrying new friendships and a renewed sense that they are part of one galactic community. Over time, the political landscape of a galactic humanity might evolve into forms we can scarcely predict. Without the ability to govern centrally across light years, each colony is largely independent, developing its own laws and social systems. Instead of a single galactic empire ruled from Earth, it's more likely we'd see a commonwealth of worlds, an alliance united by shared values and voluntary cooperation rather than by force. Earth might hold an honored place as the historical and cultural heart of this alliance, but it would be one voice among many. Each world contributes its unique perspective, and all recognize that wisdom can come from any corner of the cosmos. Leaders from different planets convene not to issue edicts, but to coordinate on matters affecting them all, maintaining the interstellar communication network, ensuring that trade and knowledge flow freely, and coming to one another's aid in times of need. With distance comes diversity. The art and literature of different worlds flourish in myriad directions. Imagine the music born under different skies. A ballad composed on a world with thin air and echoing canyons might have haunting, drawn-out tones to carry sound farther. On a light gravity planet, musicians craft enormous harps and drums that produce resonant, low-frequency sounds to match the leisurely pace of life there. Storytellers on each world weave myths blending human memories of Earth with features of their new home, tales of the first sunrise under two suns, or legends about constellations seen only from their sky. A library on one planet might be filled with epic sagas about the voyage from Earth and the founding of their new society, while another world's library overflows with stories imagining futures that even we haven't dreamed. Science and technology progress along unique paths on far-flung worlds. A colony around a red dwarf star might become expert in bioengineering crops that thrive in dim light. Another, on a high-gravity world of towering mountains, might pioneer new materials and construction methods to build safely despite the heavy pull. A space habitat with a closed ecosystem might develop advanced recycling and life support techniques that surpass anything planet-side. Crucially, they share these innovations through the interstellar network, uplifting each other. The separate branches of humanity collaborate like pieces of a great puzzle that, when put together, reveal a richer picture. One world solution to a challenge often aids another facing a similar problem, since at heart the needs of people remain alike: food and water, shelter and community, meaning and hope. In the expanses between the stars, fleets of unmanned vessels, automated cargo ships or exploratory probes, shuttle slowly from one colony to another. They carry physical goods that can endure long journeys, perhaps rare minerals or novel medicines, exquisite artworks or recordings of cultural events, even seeds and genetic material to broaden another world's biodiversity. These ships drift silently through the dark for decades, guided by AI pilots and occasional remote updates when they pass a communication relay. When one finally arrives at a colony's outskirts, it's cause for quiet celebration. People gather as the craft docks at a spaceport or enters orbit. They unload its precious cargo and discover personal parcels as well. Letters stored digitally, libraries of new books and holovids produced on another world, or samples of soil and water from a sister colony sent as friendly tokens. In a sense, these ships play the role of ancient caravans or clipper ships crossing terrestrial oceans, slow but steady links that strengthen bonds over the centuries. Humanity might even create new kinds of shared spaces, not tied to any single world. Picture a vast space station at a crossroads of interstellar travel, equidistant from several colonies, a neutral meeting ground where travelers from different planets converge. Within its rotating habitat rings, the simulated gravity feels much like Earth's, a deliberate choice to provide comfort and remind everyone of their common origin. The station's enormous windows look out on starry space, with no single planet dominating the view, symbolizing that here all stand on equal footing as people of the cosmos. Pilgrims and pioneers alike come to trade goods and knowledge, to study at an interstellar university, and to participate in a council where matters affecting many worlds are discussed. In its grand hall of archives, one can access the collected history and art of numerous civilizations, the diaries of early settlers from dozens of planets, recordings of alien winds blowing through extraterrestrial trees, treaties that have kept the peace, and the cumulative scientific wisdom of humanity spread across the stars. This station might bear a name like Unity or the Nexus, shining as a beacon of cooperation amid the dark. As our civilization extends outward, we may also encounter life that did not originate on Earth. For centuries, we have scanned the sky for any sign of extraterrestrial intelligence. So far, the stars have kept their quiet secrets. But perhaps one day, on some far-flung planet, our explorers discover ruins of an alien city, long abandoned, yet whispering of minds that once built wonders. Or maybe, in the middle of routine communications between colonies, a new signal appears, a faint, structured radio pulse coming from a star where no human probes or settlements exist. Imagine the moment analysts realize the signal is not random noise, but a greeting from another intelligence. The realization that we are not alone would ripple through every human world. Perhaps on each colony, people stop to listen as the message is played over whatever serves as the public broadcast system. It could be simple, sequences of prime numbers or a repeating series of pulses, but its pattern is unmistakably crafted, not natural. In that moment, humanity's many branches would feel a sudden unity, bonded by the knowledge that we as a whole have an interstellar neighbor. We might coordinate a collective response, crafting a reply that speaks for Earth and all her distant children together. The greeting could include music from various worlds, a collage of mathematical concepts and pictures of humans in all our forms, sent with hope into the dark. And then we would wait, perhaps years or decades, for the next word in the cosmic conversation. If a living alien civilization were to answer back, or if one day their ships or ours closed the distance, it would mark the beginning of a new chapter of galactic society. We can imagine a day when human ambassadors stand beneath the sky of another species' homeworld, or when alien travelers visit Earth or our colonies, marveling at our art and biology as we marvel at theirs. The exchange of knowledge could be transformative. Trading star maps, scientific insights, philosophies, and art forms. There would surely be challenges, differences in language, biology, and thought that demand patience and creativity, but the effort would be guided by mutual curiosity. Meeting another intelligent life form might even deepen our appreciation for the diversity of life and for each other. In reaching out to an other, we might see ourselves more clearly as one people. All the petty divisions among human cultures could seem trivial in comparison to the gulf between human and alien, and thus bring us even closer together. Even without encountering aliens, the sheer scale of expanding into the galaxy changes us profoundly. We become accustomed to thinking in long spans of time and distance. Projects that once seemed impossibly ambitious, endeavors lasting centuries or millennia, become part of our normal planning. For instance, constructing a massive space habitat encircling a distant star might take generations, but in a galactic society, we have the collective patience and foresight to see it through. After all, our ancestors planted trees, knowing they would never live to sit in their shade. By analogy, we might begin ventures whose rewards will be enjoyed by people far in the future, on worlds we ourselves will never see. Living among the stars also gives us a profound sense of the fragility and preciousness of life. Each colony, no matter how advanced, depends on maintaining an environment where humans or post-humans can survive. Whether it's a sealed dome on a moon, a terraformed exoplanet with carefully balanced ecosystems, or a giant space station, life support is an ever-present concern. This makes environmental awareness second nature to spacefaring societies. The air, water, and soil, or their artificial equivalents, are monitored meticulously. Everyone is aware that their community's survival hinges on a delicate equilibrium. Such awareness fosters deep respect for ecological balance. Humans on distant worlds might celebrate an Earth Day of their own to honor the principles of environmental stewardship that keep their new homes livable. They might hold ceremonies to thank the forests in their biodomes, or the algae in their life support tanks, the green friends sustaining them, much as ancient cultures gave thanks to rivers and rains. In turn, this ethos reflects back to Earth itself. Viewing Earth from light years away, as a pale blue star in someone's sky, may teach all of humanity to value our original biosphere even more. The more we create self-sustaining gardens in space, the more we appreciate the immense, intricate garden that is Earth. And as news comes in of hardships or triumphs on distant worlds, perhaps a crop failure on one colony and the heroic efforts of another to send emergency supplies, or the successful greening of a once barren moon, people everywhere feel a kinship in the shared struggle to protect and nurture life. Earth, once the only world we knew, becomes one of many, but it also stands unique, the wellspring of life and consciousness in the galaxy. Its role as a teacher and a treasured oasis may only grow. Back on Earth, even as centuries and millennia pass, it remains a vibrant world, a bustling hub where old and new converge. Earth might host the central archives of human history and culture, a living museum and library open to all of humanity. Scholars from across the stars could come to stroll through the ancient ruins of Giza or Machu Picchu to see the cradle of civilization with their own eyes. Perhaps Earth becomes a place of higher learning and diplomacy, home to universities where citizens of many planets study side by side, and to meeting halls where interstellar councils occasionally gather under the same sky that watched humanity's first steps. At the same time, Earth continues to be home to billions who live their daily lives in the familiar rhythms of sunrise and sunset, ocean tides and rains, much as they did ages ago. It may be less central to the daily governance of far-off colonies, but it remains beloved, the sentimental heart of human space. Earth's importance might be cultural and historical more than political. It likely wouldn't rule distant colonies by decree. Each world would govern itself. But Earth could serve as a mediator and a source of shared identity. Perhaps Earth hosts the grand galactic festival now and then, or a kind of Olympic Games of the stars, fostering friendly competition and camaraderie. Maybe spacefarers, before setting off on a long voyage, still take a traditional oath that originated on Earth, promising to uphold certain values during their journey, like respecting any life they find and helping those in need. Such customs, born on the homeworld, could knit through all communities to remind everyone that, scattered though we are one people. And what of conflict in this far-flung human tapestry? It would be naive to assume everything is perfectly harmonious. Humans, in all our forms, will always have disagreements and struggles. There might be misunderstandings or competition. Perhaps two colonies vie for rights to a particularly resource-rich asteroid. Or there's an ideological rift about how to approach contacting a newly discovered alien microbial life. But with the challenges of distance and the unforgiving nature of space, cooperation is not just idealistic, it's practical. A world suffering a crop blight might depend on shipments of food from another to avert famine. A spacecraft in distress in the gulf between stars must rely on whichever outpost or vessel is nearest for rescue, no matter any political differences. These realities instill a sense of camaraderie, a realization that we are all in this great journey together, tiny lights among an immense darkness. Disputes, when they occur, are likely tempered by a cultural emphasis on dialogue and mutual aid, forged from an understanding that survival out here often hinges on trust. If two colonies grow wary of each other, representatives can convene at a neutral station like the Nexus, talking through their issues in person or via real-time holograms if distance allows. There, under the gaze of peers from many worlds, they're encouraged to find common ground. Often the mere passing of time helps. By the time a heated complaint travels light years to reach the other party, immediate passions have cooled, perspective gained. And unlike in eras past, a war across light years is logistically daunting and morally bankrupt when each side may not hear from their forces for years. More often than not, disputes resolve through patient communication, treaties, and the gentle pressure from neighbouring societies that peace is better for all. Imagine a scene, perhaps many centuries from now, on that neutral space station beneath a dome of stars. A council meeting is in session. Representatives have arrived from a dozen different star systems. They differ in appearance, some tall and willowy from a low-gravity moon, some compact and stout from a high-gravity planet, others accompanied by graceful robotic forms housing conscious AI who speak as members of their society. They wear different traditional garments or modern suits, displaying the symbols of their worlds. They speak different first languages, but as each one speaks, the others hear their words translated instantly into a common tongue through tiny earpiece devices or neural implants. Around a circular table they sit, for the circle has long been a symbol of equality, discussing matters that concern them all. Maybe one issue is the protection of a newly discovered primitive life form on a distant planet, how to study it without harming it. Another is the coordination of a vast telescope array spread across multiple star systems, requiring synchronicity and data sharing. There are debates, certainly, differing viewpoints shaped by the unique experiences of life under different skies. But the debates are respectful, and each representative listens keenly, knowing that every voice brings a piece of the puzzle. During a pause in proceedings, the delegates take a break and drift over to the observation deck. Through the clear dome, against the blackness of space, one pinpoint of light is highlighted with a subtle overlay on the glass. It's labelled Sun, Earth's star. The delegate from Earth, Perhaps an elder statesperson or a historian points it out proudly to the others. They all gaze for a moment at that tiny, distant sparkle. For some, it's the first time seeing it with their own eyes, rather than on a screen. A humbling experience, seeing how tiny the origin of all humanity appears from here. One of the AI beings remarks, perhaps in a thoughtful, synthesized tone, that in that ray of starlight, taking hundreds of years to reach here, is the image of Earth as it was long ago. A quiet falls as they contemplate time and distance. Then someone starts humming a gentle melody, an old spacer's lullaby about longing for home, and others join in softly, each in their own language, creating a peaceful harmony. In that moment, any differences between them melt away. They stand shoulder to shoulder, children of Earth, however far removed, united in gratitude for the journey that brought them here, and in hope for the journeys yet to come. Such a galactic society is both awe-inspiring and reassuring. It tells us that no matter how far we travel or how much we change, we can maintain a thread of continuity, of memory, kinship, and purpose. It suggests that humanity has a future, not just for the next century or the next millennium, but for ages upon ages. In a way, we will be planting seeds of civilization that could, if we are wise and fortunate, last as long as the stars themselves continue to shine. But of course, even the stars do not shine forever. As our imagined future stretches further forward, we must turn our thoughts to an even grander horizon, the ultimate destiny of life and intelligence in the universe. What lies beyond the span of millennia, beyond even the scope of our galaxy? We have ventured so far in imagination, and yet there are realms further still, times and places so distant that they almost elude comprehension, and yet they remain tied to the same question we have asked from the start. How far can life go? How eternal are our horizons? And so we venture into the furthest future, to contemplate the fate of our descendants on cosmic timescales. By the time a galactic civilization is flourishing, our ambitions may turn to realms even beyond our Milky Way. The Milky Way, vast as it is but one island in a sea of billions. The distances between galaxies are almost inconceivable. Millions of light years of mostly empty space. Yet what was inconceivable to one generation becomes the challenge for another. It might begin with simple curiosity. After spreading through our own galaxy, we gaze across the intergalactic gulf and wonder what lies in the next galaxy over. Perhaps the first steps beyond the Milky Way will involve sending probes, much like our early interstellar efforts, but on an even grander scale. A tiny, durable probe carrying human memories or an artificial intelligence might drift for eons across the darkness, eventually reaching the outskirts of Andromeda, our nearest large galactic neighbour. If it arrives, it could awaken and start relaying observations, or even begin to prepare the way for larger vessels, perhaps by assembling communication relays or scouting for habitable zones. It sounds like science fiction, and indeed it is, but so once were rockets and smartphones, and the very idea of travelling to the moon. In time, we may develop propulsion methods that make even intergalactic distances attainable. If we unlock secrets of space-time, a true warp drive or traversable wormholes, a journey to Andromeda might take mere years or days instead of millennia. Without such breakthroughs, Patience and persistence become our starship. Over thousands, maybe millions of years, generation by generation, humanity, or whatever we become, could slowly diffuse into neighboring galaxies using advanced but sublight travel. We might establish way stations in the intergalactic void, perhaps enormous space havens that harvest the sparse hydrogen atoms drifting between galaxies for fuel, turning cosmic desolation into pit stops for wanderers. In this way, the gulf between galaxies could be bridged by a chain of stepping stones laid down over epochs. One could imagine an intrepid crew establishing such a station in the vast darkness, a lonely oasis between galaxies. In the emptiness between stars, their artificial mini-sun, perhaps a fusion reactor or captured comet continually ignited, provides light and energy. They tend gardens in pressurized domes, draw hydrogen from the void, and maintain a beacon to guide those who follow. For them, the Milky Way and Andromeda appear as faint, distant swirls of light on opposite horizons, each a reminder of the communities that lie far beyond sight. These pioneers live quietly, purposefully, like lighthouse keepers on a cosmic ocean. Perhaps once in their lifetime, a ship from the Milky Way stops by, bringing news from home and taking on supplies before venturing on. When that ship departs toward Andromeda, the station crew waves farewell and returns to their vigil, knowing it may be many years before they see another visitor, but also knowing that they stand at the frontier of a new age, helping to connect two galaxies. At last, we can picture humans, or their descendants, standing on a world in the Andromeda galaxy. Their night sky is ablaze with stars, somewhat different from those seen from Earth. Looming large and spectacular is something no human has ever seen directly. The entire Milky Way galaxy, visible as a faint, elongated mist of light across their sky, another galaxy seen whole. Within that glowing band lies the Sun, our original star, though it's far too distant to pick out among billions of others. Perhaps these settlers give that misty river of light a name in their own language, something poetic that means the home galaxy, and teach their children to point to it with pride. Standing under alien constellations, they feel a profound connection. Their feet press into the soil of one galaxy, while their eyes behold the galaxy that birthed their kind. In that moment, the achievement of crossing intergalactic space becomes real in a way history books could never convey. The Milky Way, once a cradle and entire universe to humans, is now a glittering swirl in Andromeda's sky, a beautiful memory shining from afar. Over extremely long timescales, galaxies themselves are not static islands. Astronomers of our time predict that in about 4 billion years, the Milky Way and Andromeda will begin to merge in a colossal, slow-motion collision. Long before that happens, if intelligent life still thrives, we may have populations in both galaxies who will witness that cosmic dance from both perspectives. Future beings will look up to see the night skies changing in ways no human has ever seen. Generation by generation, Andromeda's haze of stars will grow larger for those in the Milky Way, and vice versa. Eventually, the two galaxies will meet, their stars mingling like two great cities merging into one. New stars will ignite as massive clouds of gas collide and condense. Perhaps for a time the night sky will fill with brilliant newborn stars and glowing nebulae. The beings of that era, whether they are humans, transhumans, or AI, or some amalgam, won't just be passive spectators. They will likely actively adapt to and even gently engineer the events of the merger to protect themselves. They might calculate that in a few million years, A dense cluster from Andromeda's core will sweep near a settled system in the Milky Way. Far in advance, they could act, using gravity tractors to subtly alter the orbits of vulnerable planets, or even reposition entire habitats out of harm's way. Perhaps they'll shield planets with giant magnetic fields or solar sails to divert cometary barrages triggered by the merger. It's even possible they'll see opportunity amid the upheaval. As the galaxies intertwine, some stars will be thrown into new trajectories. Regions of space previously out of reach might drift closer. New worlds, freshly jostled into habitable zones or unveiled from behind cosmic dust, could become accessible. The merger could be a time of blossoming as well as danger, a chance to spread life into pockets of space that were once inaccessible, using the chaos of cosmic change to sow new seeds. By then, humanity might not look much like it does today. Through biological evolution, technological augmentation, and perhaps integration with artificial intelligences, the line between human, machine, and something beyond either might blur. But whatever form intelligence takes, it will likely cherish its own continued existence and heritage. So as stars collide and reshuffle, these far future societies will act to preserve what they have built. One could imagine them even harnessing immense technologies to gently guide stars. Yes, moving entire stars over millennia with carefully orchestrated gravitational nudges to ensure that inhabited systems are shepherded to safety during the galactic collision. To our present minds, that sounds impossibly far-fetched, but to a civilization for whom stars are as malleable as clay, as we may become given billions of years, it might be just another engineering project born of necessity and care. As time marches from millions to billions of years, the universe enters new stages. The bright, massive stars that lit the early cosmos will all have died out, ending in supernova fireworks that briefly outshone galaxies before fading. The night skies of inhabited worlds in the far future will lack those brilliant blue-white beacons. Instead, they will be populated mostly by the long-lived stars, orange dwarfs and red dwarfs, which burn their fuel so slowly they can outlast galaxies. These dimmer, steadier stars will be the reliable hearths around which life huddles in the deep future. Our descendants, or perhaps whatever intelligence comes after us, may cluster around such stars as the last refuges of warmth in an aging universe, much as travelers gather around the last fires on a cold night. To power their civilizations in that epoch, advanced beings could harness starlight with monumental constructions. We imagine them building Dyson spheres or swarms, enclosing stars in shells of solar collectors to capture every precious photon. From afar, an occupied star might grow dim or nearly dark in visible light, hidden behind a cocoon of technology. Up close, life would thrive on the habitats orbiting in those swarms, illuminated by the captured sunlight. Picture living on the inside of a Dyson sphere. Above you isn't a sky, but the inner curve of a vast sphere dotted with cities and parks, all bathed in the gentle radiance of the central sun, which is now controlled to mimic day-night cycles as desired. There is no natural night except what the inhabitants create, perhaps by arranging segments of the sphere to darken in turn. In some regions, it might always be afternoon, while others enjoy an 8-hour night by turning their panels away from the light on schedule. Children growing up there might initially find the idea of a starry night strange, something you only see in planetariums or history simulations. Field trips might be organized to special observation outposts on the sphere's exterior, where, shielded and suited, people can go to witness the universe beyond, to see actual stars glittering against blackness, and perhaps gaze upon the galaxy from which their star is now mostly hidden. How awe-inspiring and humbling those trips would be, reminding even a Dyson sphere dweller that there is a vast cosmos outside their engineered world. If a civilization becomes advanced enough to construct Dyson swarms around not just one star, but many, then indeed they approach the status of a Type 3 civilization, one that commands the energy of an entire galaxy. If humanity ever reached such heights, the Milky Way would be transformed. From an outside perspective, distant observers might notice the Milky Way's stars winking out one by one in visible light, as more are enveloped in Dyson shells or energy-absorbing infrastructure. Instead, the galaxy might glow in infrared, waste heat from trillions of lives and machines working to utilize starlight to its fullest. It's even been hypothesized by some of our scientists that if such civilizations exist in the universe, we might detect them by this infrared signature. So far, scanning the cosmos, we haven't found clear evidence of any other galaxy-spanning life, which either means such life is exceedingly rare or very good at evading our notice. Even a galactic civilization, however, must bow to the passage of cosmic time. Stars are born, and after their long lives, they die. The smallest red dwarf stars can burn for trillions of years, but eventually, even they will exhaust their fuel. In a future so distant that the Milky Way and Andromeda have long since merged and settled, perhaps 1 trillion or more years hence, star formation will peter out. The great stellar nurseries will have been used up or locked away by mega engineering projects. The galaxy, once sparkling with new stars, will grow old and quiet. One by one, like candles in an enormous hall, the lights will go out. As this era approaches, the galaxy's inhabitants, be they evolved humans, AI, or other beings, will face the dusk of the cosmos. They might gather around the remaining sources of light and energy. Perhaps they'll migrate to clusters of red dwarf stars still ticking on their slow fuel burn, or they will engineer new power sources. Around black holes, they might form communities, tapping into the energy of those mysterious objects. A rotating black hole, for instance, stores a huge amount of energy in its swirling space-time. Advanced beings could extract that via gigantic electromagnetic structures, using black holes like cosmic flywheels. They could drop matter into black holes and harness the radiation emitted as it gets torn apart and heated, turning the deadly gravity wells into enormous generators. Survival in an aging universe will demand immense creativity and adaptability. To endure in a cosmos growing dark and cold, life must make do with less and less. Our remote descendants might become masters of efficiency, ensuring not a single photon is wasted. They might recycle everything in perfectly closed loops, where even atoms are reused again and again in different forms. They could alter their subjective experience of time, slowing their thought processes so that a trickle of energy can sustain them for what they perceive as a rich span of time. If a machine or biological brain can be made to run at 1/10 the speed, then a given energy supply lasts 10 times longer from its perspective. Some may choose to spend long periods in a hibernation or standby state, rousing only periodically to check on their environment or communicate with others, stretching out the remaining resources over eons. Still, even the greatest ingenuity meets limits set by physics. Trillions upon trillions of years in the future, if our understanding is correct, the universe will continue expanding relentlessly. Galaxies outside our local group will have receded beyond the observable horizon, carried away faster than light by the expanding fabric of space. Our local group, essentially a merged Milky Way, Andromeda, and a few satellite galaxies, will be marooned in darkness, an island of stars in an empty cosmic ocean. Within that island, the remaining stars will gradually flicker out. Imagine the poignant scene. Somewhere, on a far future habitat, a group of beings gathers to watch their sun, perhaps one of the last shining stars, as it fades to a white dwarf, and then, after a long time, that too cools toward darkness. It might not be sudden. It could be so slow that only in retrospect do they realize the light has significantly dimmed over millennia. What songs or elegies might they compose for the final sunset of a star? At that point, all that remains as sources of energy will be things like black holes and the faint afterglow of what once was, particles of light, photons, stretched to low energies, and perhaps the occasional decay of matter if protons, the building blocks of atoms, are unstable over extremely long times. In that distant epoch, the beings that were once human, or whatever they have become, face a final choice. Can they find a way to escape this dying universe, or at least preserve some spark of themselves as the darkness falls? One speculative possibility often discussed by futurists is the creation of new universes. It sounds fantastical, yet some cosmological models suggest it might be theoretically possible for advanced intelligence to trigger a kind of controlled Big Bang, a pocket universe that buds off from our own. If such a feat could be achieved, it might be the ultimate lifeboat. Picture an ancient civilization in a cold, dim universe, pooling the last of its tremendous knowledge and resources to literally seed a new cosmos. Perhaps in a high-energy laboratory space, they compress and manipulate space-time, creating a tiny expanding bubble that, from the inside, explodes into a new universe with its own stars and galaxies. They might not be able to enter it themselves, or maybe they could send in only information, or the building blocks of life, depending on the physics. It would be, in a sense, their final gift to existence, a new chance for life when this universe can no longer support it. One might poetically imagine our universe itself was born this way, as the last act of a previous cycle of life, though that remains pure speculation. Still, the thought provides a kind of comfort that even at the supposed end, there could yet be a beginning. Another mind-bending idea is that by the time the universe nears its end, advanced beings might have transcended physical form entirely. Perhaps they discovered dimensions or aspects of reality beyond the observable, realms where energy and life could persist. Maybe they learned to upload not just into machines, but into the fabric of space-time, to spread their patterns so wide and thin that as long as the universe exists at all, they are woven into it. In effect, they could become one with the cosmos, a diffuse consciousness flickering in the final particles and fields. This drifts into the philosophical or spiritual, the boundary where science meets something like mysticism. It echoes ancient human ideas of becoming one with the universe, or achieving a kind of eternity in union with the divine. In a secular but poetic sense, it could happen via technology, so advanced it's indistinguishable from magic. Life, in its striving to survive, finds a way to persist as the universe's last light, thinking and observing until there is nothing left to observe. Whatever the ultimate fate of intelligence, these contemplations instill both humility and a curious hope. On one hand, they remind us that our universe had a beginning and will have an end, and that everything we know is transient on a timescale so vast, it's almost immeasurable. On the other hand, the fact that we, a species that once chipped stone tools and huddled around campfires, can even project our minds so far into the distant future and imagine paths through the darkness, speaks to something indomitable about life. We are still that child picking up seashells at the shoreline of the cosmic ocean, wondering what lies beyond the horizon. The difference is, now we can picture ourselves building a boat, and then a fleet, and eventually a vessel, capable of braving even the wildest seas of time. Stepping back from these far future vistas, let us gently return to the present, to the now, where all great journeys begin. All those distant possibilities, intergalactic voyages, eternal life strategies, cosmic finales, begin with the steps we take today and in the coming centuries. Here we are, in the early 21st century, as of this narration's creation, already taking tentative steps beyond our world. We've sent humans to the moon and rovers to Mars. We have a space station where people of multiple nations live and work side by side, orbiting Earth every 90 minutes. Our robotic probes have touched the outskirts of the solar system and sent back faint whispers of what lies beyond. We've built telescopes that catch the faint light of the first galaxies and see planets circling other suns. These are small steps, yet momentous. The first flickers of dawn on a long road ahead. Knowing the vast possibilities that might await can inspire how we live now. It gives us perspective, both ambitious and cautious. Ambitious because we realize our actions could set in motion a chain of events, leading to a thriving civilization lasting eons. Cautious, or rather conscientious, because we understand the rarity and preciousness of our situation. This blue world teeming with life. This era where we have the chance to set a positive trajectory. We owe a duty to ourselves and those future generations to take care of our home planet, even as we reach for others. The dreams of starships and immortality shouldn't make us neglect the ground under our feet and the society around us. In fact, those dreams can motivate us to solve present problems, to unite as a species, to foster peace and curiosity, to preserve our earthly garden so it can give rise to the gardens of other worlds. Our journey through space travel, fantasies, and futurology is nearly at its end, but the real journey, the journey of humanity beyond Earth, is just beginning. To close our eyes and truly imagine, it is almost like meditation. Let's ground ourselves in a few last human moments among these cosmic visions. Picture a night not far in the future, perhaps a couple of centuries from now. A child stands on the balcony of a settlement on Mars, looking up at the evening sky with the same wonder children have on Earth. She sees the sun as a small, bright disk dipping below the rusty horizon, painting the thin sky in hues of blue-grey and orange-brown. A Martian sunset, subtly different from an earthly one. In that dusk, a point of light emerges. Earth, a tiny bluish-white star. Maybe her parents or teacher have told her stories of that distant world. So far now that a message takes minutes to travel between planets, yet still close enough that people shuttle back and forth regularly. As the first stars peek out, far more sharply than under Earth's thick atmosphere, she spots the evening star, which on Mars is not Venus, as it is for us, but maybe Jupiter hanging low, or Earth itself depending on the timing. She makes a wish, following a tradition passed down from old Earth. What do children on Mars wish for? Perhaps for adventure among the dunes, or for the health of a grandparent back on Earth. Or maybe to one day visit that little blue dot in her sky that she's heard so much about. In her heart, the same spark of curiosity burns that drove her ancestors, a desire to know what lies beyond the next hill, the next planet, the next star. Now picture another scene, farther ahead in time. A young person on a planet in the Alpha Centauri system, the nearest star system to our own. It might be one of the first truly Earth-like exoplanets humanity colonized. In the sky above her rise two brilliant suns, for Alpha Centauri is a double star. Sometimes they dance close together, other times one sets before the other, creating double shadows on the ground. She has grown up with dual sunsets and a night sky where, if she knows where to look, our sun is just another prick of light. It's likely she's never been to Earth. It's over 4 years away by even the fastest signal, but she has seen images and simulations. Perhaps her school has a whole curriculum on origin planet studies. One evening, she hikes up a ridge where the view of the sky is wide. With the help of a handheld guide, she pinpoints which star in the sky is Sol, our sun. To her eyes, it's unremarkable, one star among many, but knowing what it represents makes her feel a rush of connection. Around that star orbit, all the legends of her history, the blue world with its rich life, the moon that humans first walked on in 1969, a date that to her is as distant as dynasties of pharaohs are to us. The whole saga of evolution and civilization that led to her own existence. She might whisper thank you toward that tiny light, a quiet homage to her forebears. Perhaps she carries a locket with a pinch of earth soil encased in glass. A family heirloom handed down from the ancestor who first emigrated to this planet. On nights when both suns have set and darkness falls, she likes to hold that locket and stargaze, finding comfort in the idea that across the light years, others of her kind are gazing up too. Finally, imagine ages and ages from now, a lone traveller, human, or whatever humanity has become, far from any recognizable world. Perhaps he is on a vessel, cruising through intergalactic space, on a voyage that has already lasted thousands of years, with the Milky Way now just a faded patch of light behind him. Or perhaps he floats in a protective suit, working on some station that hovers between clusters of galaxies, where the void is truly immense. Around him, the sky is not the familiar star-filled canopy, but mostly black, with only faint smudges of distant galaxies visible, like tiny oases of light separated by vast gulfs. He's far from any home, yet he carries home in his heart. He pauses from his tasks and looks out into the infinite night. In one direction, almost indiscernible, lies the combined glow of the local group's galaxies. Somewhere in that glow is where Earth once was, though its star might be long extinguished by now. He remembers a story passed down through countless generations, or maybe stored in his consciousness as part of his foundational knowledge. The story of a small planet where life first became aware. He might speak aloud, to himself or an AI companion, saying, "We really came this far." There in the dark, perhaps he recites a poem learned in childhood, something ancient, like a verse from Sappho or Whitman, or a fragment of song that accompanied humanity's first steps into space. His voice is steady and calm, and only the hum of the suit's systems or station breaks the silence. In that moment, he feels the weight of history and the weightlessness of the cosmos all at once. He knows that in his very being, in his voyage, the universe is hearing its own story, a story of atoms that assembled into conscious minds and set out to see everything. And so, we come to the gentle end of our odyssey, from the dawn of our interstellar dreaming to the twilight of the universe. We have journeyed together in imagination. We envisioned starships venturing through interstellar night and new Earths under alien suns. We explored the bending of light speed limits and the unshackling of life from its terrestrial chains. We saw societies knitted together across the light years and minds pondering the end of time itself. Through it all, one theme remains constant: the extraordinary resilience and creativity of life, especially of us, humble humans who dared to step beyond our front door into the vastness. As we conclude, take a moment to step outside, literally, if you can, or in your mind's eye, and look up at the sky. The stars you see twinkling above are the same ones that inspired our ancestors to tell stories and seek patterns. Those distant lights have guided sailors across oceans, and now they guide our dreams across the cosmos. Each one is a reminder that there are countless destinations and possibilities beyond our sight. We stand here at the shoreline of the cosmic ocean, as one famous astronomer aptly put it, having dipped our toes in and found the water inviting. Tomorrow, and the day after, and in the years to come, we will build our ships and venture further out. Each generation will push a little more, never exhausting the wonders that await. No matter how far we travel, we will carry with us the essence of home. In every distant world we settle, in every artificial habitat we construct, there will be echoes of Earth. Maybe it's in the plants we grow, a rose in a Martian greenhouse, a pine tree bonsai on an orbiting station, wheat fields under the glow of another sun. Maybe it's in our rituals, a New Year's celebration timed to Earth's orbit, even if that concept becomes abstract on a planet with a longer year. Certainly it's in our hearts, for Earth is the place that forged our very souls. We are made of star stuff, as the saying goes. The elements of our bodies were forged in long-dead stars. But we are also unmistakably made of Earth. The water in our veins, the iron in our blood, the songs and lullabies we inherit, all are parts of this beautiful planet that will accompany us to the stars. This journey beyond Earth has no final ending, only endless new beginnings. Every question we answer about the universe opens a dozen new questions. Every horizon we reach reveals another beyond it. Instead of this discouraging us, it can inspire a deep peace and purpose. There will always be more to learn and more to explore, and thus always reason to strive, to hope, and to dream. In a sense, as long as the universe exists, the journey of understanding and discovery will never be complete. We become, in effect, immortal as a collective story, a story that began on a small planet and chapter by chapter is written among the stars. So, as this narration draws to a close, let your mind drift among those stars one last time. Feel the wonder, but also the calm that comes from seeing the big picture. We are so small in scale, and our lives so brief. And yet, we have significance because we are part of this grand, continuing narrative. The night sky above you isn't just a backdrop to daily life. It's a direct link to everything that has been and everything that could be. The photons hitting your eye from a distant star might have left that star before you were born, travelling across the abyss to meet you here and now. In that simple act of looking up, you are connecting with a vast cosmos that, despite its unimaginable scale, is knowable bit by bit. Thank you for journeying with me in spirit on this long voyage through space and time. May your own dreams be as boundless as the cosmos. May you find comfort and inspiration whenever you gaze at a star, knowing that that twinkle has travelled far to reach you. and that someday, perhaps, we will travel just as far. Our exploration beyond Earth is only at the beginning, and each of us carries a piece of that beginning within us, in our curiosity and our courage. Now, rest easy and carry these visions into your dreams. Under the quiet night sky, remember that the darkness is not empty. It's filled with our questions, our stories, and our collective destiny. As you close your eyes, imagine the gentle arc of the Milky Way above. Imagine other eyes in other worlds looking at their skies, and realize that we are all part of a tapestry as old as time and as wide as space. The universe cradles us, and we in turn give it meaning by marveling at it. Good night, and keep looking up at those stars.